Actually, this week is little lengthy. Some things would have been in the next week.
Actually, the thing should have been like we are already preparing for the quiz 2, and again we have to also solve week 9 also. It becomes very haphazard to plan.
When will they
Right.
stop this assignments so that we can get prepared for the quiz too?
So I think today is the last thing. After this, you will not get, like, normally you get your graded assignment submission on Wednesday, right? So I think for week 10, we are shifting it to after your exams. So maybe you will be getting another week for
Hope you
week
give
10.
us little more time.
Yeah,
And
you're getting a lot for
Sir,
week 10.
week 10 is
But
mentioned as the 9th March in the.
right. That will not be happening. We'll be rescheduling it.
Okay,
And so one
thank you.
more thing, in case, for example,
Thanks a
whenever
lot,
the
sir,
week
for this.
4
Thanks a lot.
ends, like week 8 has ended and we have started gradual, we have started with week 9. So we have got no time to look back, and we are again looking at new and fresh things
Yes, sir.
wherein
Yes, sir.
we
This
will
is the
not have
problem.
time to really revise the concepts from week 5 to 8.
Yes, sir. Same here.
Oh,
So
sorry, I
working
didn't get.
professionally becomes
No,
very difficult.
Actually,
So-
this week 9th will be finished by tomorrow. So after that,
Yeah. After that, you don't really have to focus
you
on
don't need
week
to
10.
focus on 10. That's what
Yeah.
someone's telling me.
Okay,
It's
okay, get it.
your deadline is extended.
Will be a
I mean,
revision.
will be extending. Yeah, there will be a revision session for your quiz. So I hope you know that your mock
Sir, one
exam.
thing I would like to know in quiz 2, what proportions of week 1 to 4 and what proportions of week 5 to 8 would be coming in quiz
See,
2?
majority are from week 5 to 8. Very minimal, you can say, from week 1 to 4. What do I mean by very minimal is, like, you don't have a direct question from week 1 to 4. It will be like intermixed with your further weeks.
Like the distance formula question in grade
So yes. So you won't be asked directly, like, a specific question which is based on purely of week 2, or let's say a week 3, or let's say a week 4. It won't be like that. If I want to ask you a logarithmic question, what I'll do is I'll give you a composition of functions. So it will be log of some polynomial. So for doing this log thing, you must know polynomial, right? Right. I mean, at least some part of it. So that's why we say, like, from week 1 to 8, but you will not get any direct question as such from week 1 to 4, but definitely you will find these weeks being intermixed with your other thing. So that is certainly going to happen.
Okay, sir, got it.
Sir, I have a doubt.
Yeah.
So actually, even though I have gone through the videos and everything, the lectures, what professor has taught,
Okay.
there were some formulas which he has given for the trigonometric functions, inverse. It is regarding the secant square. He has given a different formula. So what I think is the integrals are always inverse of derivatives.
Right. Not very always, but of course you will have some constraints.
If secant of tan x, secant into tan x is equal to tan x.
Okay, so one thing I would like to say is, like, you don't really have to worry about the formulas. I mean, in a way, like, you have to memorize or something.
No, this is for integral. Integral, what I meant.
Okay, fine.
Yeah.
Yeah, for that also I'm telling, like, you don't really have to memorize the formula. We will give you formulas.
In the exam also?
Yes, in the exam as well. So we'll give you formulas. So
Mm.
maybe like for integrals and also most likely integrals, limits, and differentiation. Like, this is where you have a lot of formulas, right?
Yeah,
So
too many.
maybe like these weeks we'll give you formulas. Maybe in the very beginning you see, right, like we give you some set of instructions. So maybe we can, mention those formulas then there itself. So you will have formulas with you. So don't have to worry about it. But all you have to do is like how to apply it, right? So that is something you can learn. All right. So we can start our session now. So I think we are 50 of us as of now, and 25 of you have connected.
So you were saying something about the mock exam?
Yeah, that's going to happen on Sunday from 7 to 9, most likely. So that is something we are planning
Coming
for.
Sunday.
Yeah, coming Sunday. So you can give that, you can attend that.
Sir, a request here.
Sorry, no. Actually, it should be 1 hour. Sorry.
Sir, can you arrange a
for
revision
4
session?
subjects,
Meanwhile,
4
since
hours.
Okay, just a minute, just a minute. Meanwhile, when we are having conversation, I want all of you to join here on peer deck. I could see only 26 of you have joined. So as soon as it reaches some 35 or 40 number, we'll start our session. So yes, what is that you were asking?
Sir, I was saying after this solve with the session, can you arrange a revision session from say week 8 and week 9 for week 8 and 9?
A revision session for particularly this today itself.
No, not today, sir. After this.
Okay, like sometime
Within-
later.
Yeah.
But,
But before the mocking.
but we don't have week 9 for the quiz 2.
Right. So that is not coming for your quiz. So all you can see, we are arranging a revision session, but that is not going to happen very soon here. It's most likely going to happen on Tuesday, I guess. So I think that is something we were thought about. So that is one thing you can count.
Sir, that
So you
means
were
this
saying
coming
something about the
Thursday.
mock test duration.
After the mock test, the revision session
Yeah.
is going to happen.
No. After mock test, there is no revision session, but you will have So after that, in the sense after a day, maybe on Tuesday. So something like
Yeah,
that.
so
Yeah.
maybe
Sir, we have a live session on Thursday and Friday. Could we have the revision sessions on that instead of covering week 10?
Exactly. Yeah.
No, we will not have any sessions on week 10.
Okay.
So we can cover on Thursday and Friday revision of the.
Or we might have one session on week 10. That is something.
Yeah,
That's
otherwise
the
we-
activity.
Yeah.
I guess this is not again fixed. So maybe you
There
will
should
get
be
to know
one.
after. Okay, so
it's
let's
a
see.
sincere request. If you keep on covering week 10, how will we get time to cover the
That's what I was
session
telling you.
earlier?
That's what I was telling you.
So if the
Like-
team can decide and if the
No. This
professors can
is
allow,
something already been decided that your week 10 graded assignment will not be immediately after your quiz 2. You will get a week gap, like a complete week gap. So maybe you will have some more days. I say it will be like some 8 to 10 days you will have for your week 10. So we'll take all your live sessions there. So you don't really have to think about that part. So
So
that is
we
okay.
do have a live session this Thursday and Friday, right?
No. You just have it on Friday. You don't have a live session
Oh,
on Thursday.
sorry, not on
So
Thursday,
on
on Friday. So
right.
the Friday one, can we please have a revision for weeks 5 to 8? Please.
So that's what I was telling you.
Excuse me,
Like
sir.
you have a revision session on Tuesday. Because revision sessions should happen, some days near to your exam, right? So like when we are keeping it on Tuesday, so let's say you will have another 5 days for your preparation for exams, right?
But
So
we
then-
would want it even before our mock also. Then we
You
do
want it
better.
before that?
Yes. And if we have any doubts,
We can at least ask them before the mock.
there should be at least minimum 2 sessions.
Okay, fine. So
Sir,
maybe I can
actually
speak to our
other
team.
subjects we have got on-demand classes. Only maths
Exactly,
we don't
yeah.
have, which is the toughest of all for us.
Okay.
Especially this week is really
Sir.
tough.
Sir,
Yeah, but
Please-
yeah,
please-
this week is anyways not coming for your quiz too, so it's okay. Yes.
hello, sir.
Yeah. Hi.
Sir, please keep a 1 week gap between quiz 10 and quiz week 10 and week 11 because we have quiz 2 in between.
Yes. We have thought about it, and we'll be doing like that.
Okay, sir.
Yeah.
So,
no worries.
VA9 is the last assignment that we need to do before the quiz,
Yes.
right?
Yes. After this, also you'll have the graded assignments, like some kind of sessions like this. But right? This up to week 9 itself is being counted for your.
Okay.
Yeah. So that's okay.
Thank you, sir.
But we are getting like for graded assignment week 10, we date written over there, like I guess 9th March, the last date to submit that graded assignment for week 10.
9, right?
Yeah.
Week 9 is tomorrow, isn't it?
I'm talking about week 10.
So that will
Yes.
get extended. No worries.
Okay,
That will
okay.
get
Sir,
extended.
week 9 is not there for quiz, right?
Week 9 is not there.
Sir,
Only
what
5
is
to
the
8.
duration of quiz 2?
Only 1 to 8. Duration for your exam, I guess 1 hour, right?
1 hour for one subject, no?
For one subject, yeah.
So is this applicable for each subject? Like, can we consider it for English and CT as well? that they can.
I mean,
postpone.
it depends, no? Like if you have taken one subject, then you get 1.5 hours, something like this, right? And if you have taken two subjects, you get 2 hours. Three
No,
subjects.
I'm talking about grade assignment that they will postpone their.
Oh yeah, this
Okay.
one. Yeah, most likely for all
Okay.
foundation level courses.
Okay.
You are saying most likely. So if it doesn't, if they don't, if you
No,
won't,
no, it'll. I mean, most likely it'll happen
Yeah,
because
I mean,
we have initiated for maths. So and that will certainly will
yeah, it should be
discuss with the
certain.
team.
Yeah.
So
Yeah.
just I think we have bombarded you with a lot of questions and queries. Just keep 2 revision sessions and we all will be happy. At least 2 sessions will do something for us, and you replace that 10th week sessions by revision, please.
Okay, so maybe we'll think about it. So I think like it should happen, like one pre your mock and one post after, post mock revision session, right?
Yes, otherwise we'll also flunk the mock and it'll be of no use.
See, it's not much, I guess. Like now you guys are very good with week 5, 6, and if you know 7, then 8 is easy, right? So I think it's doable. You just have to put more practice.
I think
Right?
we've forgotten week 5, 6.
Okay, you've forgotten. Yeah, I know you.
I mean,
you
you
guys
just
have to
made it
read the other
easy for
subjects
us
as well,
to.
right?
I mean, you just made it easy for us to make a graph like that. That was the difficult part.
Okay.
Yeah,
so,
that was
yeah,
really
at least-
wonderful.
Yeah.
Okay. All right. So let's start our session. So today is week 9 Solve with us, and I'm Vicky Kumar Sharma, maths course instructor. So as I could see again, not all of you have joined. So I want at least all of you to participate here. So you know the thing, right? So we'll give you a question and we'll give you some 2-3 minutes to solve a question, right? And then we discuss the solutions. Most likely, I might ask you, someone who has finished who have finished the question. I might ask you to raise your hand and then discuss the solution for that particular question, and then I myself will discuss that. Okay, so that is what we'll do. So this is this because it's already week 9, so we can skip all this. So you can this is just a sample question. So how to give your response. So the question is, how is preparation for quiz 2 going on? So maybe you can just quickly write something. Good. All right. Working still on. Good. So you can see, right? Like whatever you type on the screen, I'll be able to see them. So that's the thing here. So 70% is good. That's actually good. Ongoing, haven't started yet. Okay, not well. Okay, work in progress, perfect, good, average, keep on going. Okay, maybe going to start after week 9 assignments. I think this is something even I would have done. So I mean, most of us would do that. And I think you have a lot of time after your week 9. It's like you have a lot of time for your quiz 2, right? So I think all of you should score some, I mean, at least 80% of you should pass, right? With good score. I mean, more shifted towards, towards the right hand side, like in the range of 70 to 80 marks. So I guess this is what we are expecting. And if you can do, this is only the toughest part you have here in maths, the calculus, because you have a lot to do and you have limited time. So if you are very good at this part, then I think your end term exam, I think all of you will pass with really good marks. Okay, so I see like so many of you. Okay, awesome, nice. 60% installed. Good. All right, so this is your first question. So I'll mute all. So this is the first question, and I believe like this, for this particular question, the graph was not given in the question, I guess. Maybe the graph is not very difficult to do, but since it was not given, you can always say, yeah, it was not given. So I have given it here so we can practice. So you see here the question is, this figure represents your company A, and the second figure on the right hand side represents your company B, right? You have the equations for this, not equation, but the function f1 is given to you, and f2 is given, g1 is given, and g2 is given, right? So all you have to do is like answer the questions which is asked. But here since you have been given a function, you have been given a graph, and what is been asked is, suppose the area of the region bounded by the two curves, the original curve. So here, see, f1 and f2 are the original curves, okay, and g1 and g2 are the predicted curves or the model curves, okay, and this curve represents like f of whatever and g of whatever represents basically the profit, right? And this x-axis represent your year. So here 0 indicates that x0 indicates it's the beginning of a year, and when x is 1, it represents the end of the year, okay. And here on the y-axis, it represents the profit, right? So this is what all about this graph, and you have been asked to find out what will be the difference between the minimum values of f2 and g2 in the interval 0, 1, okay. So in between 0, 1, what is the minimum value for f2 and g2? So f2 and g2 is, we are talking about the second figure. And notice what is been asked, okay, minimum value. So do not find out area and then give, the area answer. So it's asking values, right? So you can take 2 minutes and then we can proceed ahead.
Just by looking the graph, we can tell, right, this answer?
Okay, by looking at the graph, what is the answer?
From the second graph, minimum value of f2 is 0 and for g2 is 1.
Okay.
So 1 minus 0, 1.
You're smart then.
Sir, is it something wrong in this?
No, that is perfectly
I have
right.
the same opinion.
Yes, that is perfectly right. I mean, that is what you will have to do mathematically, but since the graph is given, you can straightforward do it, yes. So I should not, so I don't know why 16 of you have just given response as of now. So maybe this question is so big to read and understand, that's why it might take a 2 minute for understanding this question. So you see, in your examination, if you see any big questions, right, you keep it in your mind that big question is not going to be a tough question. It's going to be an easy question because most of the data would be given in the question. Okay, so do not get afraid with the big questions. When more informations are given, then the answers lies in that information. Just understand this. But just simple equation and a line question is given, that is more dangerous, like not much information, but you will have to do a lot in that. But this is what, like, normal tendencies, like when a big question is given, we tend to get afraid. We'll be like, oh, we don't know and all that, right? So anyhow, let's see what is the popular responses. So I can see like 50% of you have given answers. So I think most of you would have given answer. So you are telling as 1, but significant number of you are telling -1 and 2 also as the answer, right? So as it was told, the answer is 1. So the answer is 1 only. But see here, what is being asked is, what will be the difference between the minimum values of f2? What is the minimum values of f2? Simply 0. And what is the minimum value of g2? 1. So they're just simply asking what is the difference. So it's 1 minus 0, which is 1. So straightforward, we can get this answer, right? So maybe you would have seen, oh, this question looks very big, but what is asked in the question? It's very simple question, right? For which you actually didn't require all this data, isn't it? So that is one thing. Do not get afraid. And see, most of us actually tends to do, a lot of calculation, but you don't really have to do sometimes. You will have it when you have the graph. So yes. So what it was told was, like, as the function is increasing in the interval 0 and 1, thus the minimum value will be at x equals to 0. So you can just simply substitute the value also in that given function, right? If g2 and f2 is given, so you can substitute g2 of 0 and f2 of 0. What does that value give you? So you get that value. G2 of 0 is nothing but e to the power of 0, which is nothing but 1, and f2 of 0 is straightforward 0, right? What is your f2? F2 is basically x, right? So 0, right? So the difference between them is 1. All right. So do you have any doubt here? No doubt, right? This is.
Sir,
or do
if
you
in
have-
question it is given the difference between the minimum values of G2 and F2, then also the answer will be 1 or -1.
minimum values, na?
No, in this question it has given that F2 and G2. If
Okay, so
if
it's
Trying to
okay.
swap the order. Like
Okay.
G2 minus F2 and
Okay, so
F2
maybe
minus
that's why this popular answer was why they were giving answer as -1. So I get it. So it's not like this. So if we see here, we just wanted you to find F2 minus G2. Sorry, G2 minus F2. So that's why we gave it like that. But I think we should have actually given this as an absolute value if our intention was to ask just one, right?
yes, sir.
Yes, I get your point. So maybe, yeah, that is something we will pay attention to, like when we are asking that in your examination and all this. But here, the direct implication was what is difference between G2 and F2.
Sir, if it is written that minimum value of F2 and G2, then means not in this question, but in general, what should we need to do? F2 minus G2 or G2 minus F2?
See, this is again like when we say what is the minimum values of F2 and G2. So the normal tendency should be F2 minus G2, right?
If
normally difference is positive, right?
Yeah.
Always difference is positive. Na? If it is -2 also, we will tell difference is 2.
Okay.
Take the
We
absolute
won't say
value.
negative. Difference
Unless-
is always positive.
Unless until specified, right? Take the absolute value. ABS or something like that.
Okay.
So same question again. Okay, for this the question thing is changed, but the informations are same. Okay, what will be the error in prediction of a company A? Now company A is the first figure and company B is second figure. Okay, so error in prediction is basically the differences in this area. So basically they're asking you this shaded region. Okay, so solve this quickly and get the answer. Maybe we can wait for 2 minutes and then we can start. Okay, some 8-10 responses as of now. If you don't remember the formula, you can actually see formulas and then do.
Are we going to, will we be getting complex equations for integration and differentiation or just the basic ones?
Just the normal, just the normal one.
Okay.
Yeah. We won't
Normal, I
get any complex.
remember. Complex, It's like I have to brush up again.
Yeah, like some not very difficult, but and
Okay.
like very easy.
If we can figure it out in the exam hall, then that's all I want.
Yeah, the one which involves UV type, right? Integral of UV. Those types is the complex one, right? The rest all things is the formula. That's all.
But even integral of UV, it's okay. We can manage it as long as we have
I
seen
mean,
some practice exams before. So,
yeah.
but if it is something like integration of e power x or integration of x power n or something like that, then it's
Integration of
straightforward.
x power n is like, it's very straightforward, isn't it? It's like we are if you give you a formula, it's just you'll have to see from the formula and then write, isn't it?
Yeah.
So maybe at least since we are giving formula, then we shouldn't give straightforward questions.
Okay.
Yeah.
So is there a possibility that we'll get integration of UV?
Yeah.
Oh,
definitely.
Oh. So could you cover that please after the class?
Sure. We can take one question.
Thank you, sir.
Yeah. Okay, so let's discuss now, right? Or you want some more time? Do any of you need some time? What I believe is like week 9 is you have to, you should slowly build up your concepts and do the things in procedural manner. Then I don't think so then your accuracy will increase if you are doing this, at least for these weeks 7, 8, 9. All right, so I presume like you don't need much time, right? Do any of you need time? No, right? Or
No,
do anybody wants more time? That means 60%, 50% of you are participating here. Rest all are just listening, right? So, and 10%, some of you haven't joined this session as well. It's good if you join and then participate, right? That's the whole point of this session. Okay, so let's see what will be the question is what will be the error in the prediction for the company A, right? So error is basically this shaded region, right? And this first figure represents the company A. So let's see what are the popular answers. Okay, so popular answer is 1. Great, let's see. So who would like to answer this? So this is just tell me the approach. Any of maybe
Sir, first we will find the area of G1.
Okay.
Then I will
what's your good name? Sridhar, right?
Yes,
Yeah,
sir. Then
yes,
I will
Sridhar,
subtract the area of F1.
F1, and what will be your integral values? Like
integral
from what will be your limits from where to where?
0 to 1.
Okay.
And I'm getting 1 by 4.
You're getting 1 by 4. Okay.
Yes, sir. 0.
Okay. What you would have done for this figure in the second figure, if we were to ask you G2 minus F2, what will be your
integral?
What will be your limit value? What values you will be taking? The integral values, yes.
0 to 1.
0 to 1, right?
Yes.
So
Sir.
if any of you are thinking to take this as the values 0 to 2.5, do not do that. It's just this x values. Okay. So thanks, Sridhar. So I think that's a very straightforward, right? So we just have to find out the differences in these two areas. And we know that integral gives us the differentiations, right? So this is what it has been done. Now we know that the error in prediction for company A will be actually the enclosed area of that function F1 and G1 in that interval 0 and 1, right? So let's say that is our area 1. So how you get it? Integral 0 to 1 F1 of x. So F1 of x is this one, right? This figure, the lower part, this function, right? So how do you get it? So you just have to substitute these values and then do the integration part. So x cube integral is what? X to the power of 4 by 4. And now what you do, you substitute the value from 1 to 0, and then you find the difference, right? I think you know how to do this. So when you solve this, you get 1 by 4, right? So that is your F1 area. All right. So F1 area in the sense, what do we get? Actually, when you do this, you get this region, this complete region. I hope you can see my cursor. This part you get, right? When you find, and when you find the G1 area, you get this complete part. So what you do, when you subtract F1 from G1, you get this enclosed area, right? So similarly, we are calling that as an A2, whatever the area which has been enclosed here with the function G1. So I'll mute all. Okay, so you can see that our G1 was given as root A. Okay, maybe I'll mute again. So now what? So now you will have to find the integral of G1 of x with 0 to 1 as the upper and the lower limit values. So when you substitute this, so what you just have to apply the formula again, x to the power of n formula. So here n is nothing but half, right? Half. So what does it happens when you find the integral value of this? It turns out to be half plus 1, which is nothing but 3 by 2 upon 3 by 2, and then you substitute the value, you get 2 by 3. Now you should do what? A2 minus A1 or A1 minus A2? What should you do here?
Toilet.
A1 minus A2.
Should do A2. Yeah, so
A2 minus A1.
A2 minus A1 you should do here, right?
Yes, sir.
So here that is the strict condition that what you have to follow, that is A2 minus A1. So when you find the difference, that is 2 by 3 minus 1 by 4, it turns out to be 5 by 12, right? So this is the actual answer. So I hope this is okay to all of you. If you have any doubt, you can ask here.
Sir, it is F1 minus G1.
Just a minute. Can you unmute and speak? Yes.
Yes, sir. It is like it is F1 minus G1, no, sir. As per the graph.
Let's go to the graph. It should be the other way around. It shouldn't be F1 minus G1. See, because when you find F1, you are finding this region. You can see. Right?
So overall G1 and then minus the F1.
F1. Yes, yes, you got it.
Okay.
And in this question, we were given the graph by you. In case the graph is not given, how would we figure out which curve would be above the other? Would we
Draw the graph.
Draw it. But sometimes even drawing does not give us a clue. That means we have to find f of x.
See the thing.
Or you can actually get the integral value, and you will find whichever is the highest area will definitely actually give you an idea that okay, this lies up. Right?
Okay, so you just automatically assume.
Yeah. So even that is doable.
Whichever is the highest, the number for 2 by 3 is the highest, so minus 1 by 4.
Yeah. So when you're finding that, so sir, when you're finding this enclosed area, yes, please.
Sir, what will be if the similar question is asked for company B, how will we do it?
Okay,
what will you take the integration limits?
When you are asked for B?
Yes, sir.
For this one, so limit will be 0 to 1.
Same, okay.
Yeah. So you see from here to here it's been asked, right? So you will be
same area of G2 minus area of F2 from 0 to 1.
G2 minus F2, yes. That's what you will do.
Okay,
sir, every time we have to take the limit from only the x-axis. It's like 0 to 1.
Yes. You will always take from it's basically that x values you should take, right? Okay. Because when you write that integral, it's like from x1 to x. You say, right, from limit x to some value to limit x to some other value, right? So that is the x value. Okay. So now again, let's go with the
here why the error is positive here. Here the graph is given, it looks like positive, but if the graph is not given, how do we assume it as a positive error?
Positive error in the sense here it says that the error is the enclosed area.
The area will always be
positive. The graph is given. It's okay.
If the graph is not given and the interval will be given, sir.
Interval will be definitely given, and if graph is not given, you do the graph.
We can substitute numbers and approximate.
You can do the graphing part, and you can understand which is which should be the
and
enclosed
what
area.
about the intervals? 0.
Interval will always be given to you. Like we will always tell you. We'll ask you. Okay,
from 0 to 1 will be given. So how many parts it has to be divided was given through this.
Okay, graph. So this is basically here the Riemann sum and all is not coming. It's like direct integral what you do. It's the limit value is given to you, right? So that's what you do. You do the direct integration here. You don't do that Riemann sum here. So we won't be giving you any parts or something. Here parts here part means n tends to infinity.
But if they ask for Riemann sum, they will give the parts also.
Definitely. We'll tell you, okay, these many intervals you will have to take, and then we'll also mention you whether you have to do left hand or right hand or the, the average of that. So we'll definitely mention all that if we are asking. Okay. Here you just have to find the direct integral for this. Okay. All right. So I hope that was okay when you asked me this, that how will you know that? So one thing is you will have to draw the graph by yourself. If you know, you should know. So the graphing is okay. If you can do, then it's very good. And if you cannot, then just find whichever is maximum and then get the difference, like take the absolute difference. Okay.
That's how the area value will always be positive, right?
Can be negative as well, because you would have seen it in the lecture also, right? Like in your activity questions, wherein some shaded region, and here it shows the maximum regions are on the negative sides. So it's just the notation saying that this is negative area, this is positive area. It's just like that. But
take the absolute value.
Yeah, area will always be absolute of.
If the area will be below the x-axis, then it will be negative.
Definitely, like whenever we ask you, like, okay, find the area for this, we actually mean absolute value. But when something, if you want to tell you, okay, what will be the negative part of it, so it's just the indication that it is lying on the negative side of the
Like how a distance is measured, the distance will always be measured in positive. So area will always be the amount of area. So it should be absolute.
Okay, so if you would have done that activity question, one question was there, right? So we asked you the difference in that area. So there you will find the area was being negative. It's just to indicate that, it is lying on the lower side of the x-axis.
But
that's
if
all.
if it's passed in the exam and comes negative, do we enter a positive value or a negative?
I guess negative.
You will get an idea about it. So when we are asking you, we'll certainly mention that if something is being told, like, when we are mentioning some negative value, understand that it's the lower value. Okay. So don't worry about that negative positive thing. As if now consider it's positive only. Okay. Always.
Okay,
all right.
sir.
Yeah. So let's not get into that part. Okay. But it's just that to tell you, like, if area is lying below that thing, just to give you an indication that this is a negative area. That's all. Okay. There is nothing, you will have a negative area concepts, right? So on general, you should take positive value. Okay.
Yes,
I
sir.
hope I'm clear on that.
Here one thing is there, that error, what exactly it means, like when you're taking the difference between the two areas,
right?
What exactly that error means here?
So here, actually, error here, what does it see? First of all, we are defining what this enclosed area is. So we are telling this enclosed area is an error. So we are defining something here, right? So if you see in practical sense, we really have to give you a real life example wherein we can actually explain you this. But as if now you can just say that, okay, this particular question is being defined like this shaded region is the, error in the area. That's all. Or the basically, what is that? Error in prediction. Sorry, not in error in area, but error in prediction. Error in prediction is nothing but this enclosed area. That's all it means. Okay.
Okay, sir. Thank you.
All right. So any other doubt here? Okay. If no doubt, let's go with the third part of this. So here again, you have to choose from these four. So error in prediction you got now. What is error in prediction? Error in prediction is this enclosed area or this shaded region. Okay. So from these given four options, you will have to choose the best one. So first one is the correct option. So the error in prediction for a company A is more than that of the company B. So basically, the ideal thing to do is find out, you have already found out the error for this one, find the error for this, and then see which one gives you the maximum error, right? Out the minimum error, and then choose among the best, choose among these options, which is the correct options. So take another 2 minutes, solve this.
Sir,
Yes.
excuse me, sir.
Yes.
I
Yes.
have a doubt, sir. Like in the final foundation level exam, will we get any report card like mark transcript, sir? Any report card?
For foundation, I don't know about report card, but you definitely get a certificate.
But
that
any
you have.
report card where marks will be
I,
printed?
I don't know like if it is given or not, but most likely it should be given. And if it is not given, then you can always ask them to give. They might provide, right? So you can write this to support.
Yes, sir.
I mean, yeah, yes, we will get a report card as a there would be a grade mention for each subject, right?
Okay.
If you get a
Okay.
yeah.
Okay.
Yes.
Yeah.
Sir, and
Good.
this will
Thanks.
reflect the recruitment also, no? If
Definitely.
they
Like
get
if somebody, if somebody comes, they'll definitely look at your grades, right? Let's say if you qualify all these, and if you go at the end, it's your overall CGPA they look for, right?
Yes, sir.
Yeah.
Sir, thank you, sir. Thanks a lot, sir.
Yeah.
There are improvement exams as well for each quiz, I guess.
All right. So I can say most of you have given response, like 40 of you. So do you need more time or should we go with the solution?
Yes, sir.
You need some more time?
Yes, sir.
Okay. So maybe we can wait for another minute.
Done, sir.
Okay, great. So so maybe any of you can explain this. You can raise your hand. I will ask someone to explain this. Okay, Shreya.
Yes, sir.
Yeah.
So we take integral from 0 to 1 of e to the power x dx minus integral from 0 to 1 of x dx, and then we get e minus 3 by 2 for the
Okay, so just a minute, Shreya. You can actually wait. Then I'll take you to the solution page, and then you can explain. You can just tell me the approach. What you have done for figure B, you have founded the area, right?
Yes, sir.
This enclosed area. So how did you get that area?
So g2 minus f2 from 0 to 1.
Yeah, and similarly you have done earlier for this. Then
Yes.
you just compared the value,
Okay.
whichever was higher, right? Or
Yes,
you
sir.
can just simply see whichever is higher, right? And then you can choose among this. So what was your option?
Sir, B.
B, right? So B is the right one. So I can see like most of you have given this B as your answer. So good. So most of you can answer this. So Shreya, basically you would have done this, right?
Yes, sir.
Right. So you have found the area, isn't it? So Shreya, could you just tell this? How is this happening so that others can know? And I will not have to tell them.
Yes, sir.
Yeah.
So basically so we just compute the integral for f2 and g2 separately.
So basically it's the same thing, right? So here f2x from integral 0 to 1, right? So f2x was nothing but x, isn't it? Shreya?
Yes, sir.
Yeah. So, and then we do
So-
this, right? We find the
Yeah.
integral of this. Yeah, please go ahead. Sorry.
Power 1. So x to the power 1. So it'll be converted to x to the power 1 plus 1 upon 1 plus 1 which is x square upon 2. And then we just insert the, we just compute the, compute it in the given interval. That is 1 square by 2 minus 0 by 2. Then we get half. And then we do the same for e to the power x.
Okay, so you find the integral for this, then substitute the value, and then you check, right? So essentially, we'll find that a4 minus a3. So it's basically this one. Let's say this has a3 and this has a4, and then you find that difference, right? So here a4 is nothing but g2, right? So let's see, g2 is what? G2 is this. So g2 minus f2. This is what we are essentially doing here, right? And then we certainly get we get this thing, e minus 3 by 2. And e minus 3 by 2, you can substitute the value for e, and then you can actually see that this value is actually greater than 5 by 2 or 12, what we got earlier, right, Shreya?
Yes, sir.
Yeah, and that's how we got to know that option B was correct. Okay, so any doubt here? Any of you? Thanks, Shreya.
Welcome, sir.
Yeah, so no doubt, right? So let's go to the next question. Now consider this function f of x is equals to x power 5 upon 5 minus 10x power 4 by 4 plus this by this and this by this and this, right? So you are asked to find out what is the local minimum value of f attained at a critical point. Okay, so interesting question. And you have been given some hint here that x power 4 minus this whatever could be factorized, and you will get that factor as this x minus 1 times x minus 2 times x minus 3 times x minus 4. Okay, so I would be really interested to know your approach for doing these questions. So you can take some 3 minutes. Okay, just a question to all of you. Like, is there anyone here in our group right now who's writing quiz 1 again, or like who's going to write quiz on 13th? No one, right? Okay, so maybe no one. All right.
Sir, in 13th March, there is a quiz too, na?
Yeah, on 13th March, there is a quiz too, but those person who did not qualify, right? So they have this another exam, like a qualifier exam, but they'll be attending the session for the next term, but they will get, it's essentially they'll get 2 times to write qualifier. It's like that. So they will have those who were from your batch, the qualifier batch, who did not make this time. So they are given an opportunity to write again on 13th. So they can write, but they won't be continuing. They won't be with you for this term. So that's the thing. So they'll be in the next term.
Sir, pass criteria in quiz 2 is same as quiz 1, na?
So there is nothing pass criteria or something. So it's just that whoever, whatever marks you score higher, right? So let's say you got some marks in quiz 1 and some more marks in quiz 2. So your best score will be taken. That's all. So even if you fail in quiz 2, it's okay. That's not a problem.
Then I think it will affect on term 1 exam.
In a way, because that will indicate that your preparation is not good, and then and essentially, yeah. So not much with that. All right, so let's stick on to this topic now, our studies part, what we are doing. Otherwise, if we talk all that, so we'll be in that itself. Okay.
Quick question about maxima and minima. F dash should be equal to 0, and f double dash is greater than 0 for minima, right?
For minima, it should be lesser than
0. For minima, f double dash
should be lesser than 0.
Okay.
Sir, for
So
minima.
For
minima,
minima,
it
okay,
should be
sorry.
greater than
For
0.
it should be greater than 0. Sorry. My mistake.
And for maxima, it is the other way around, right? F
Yes,
double dash
yes.
should be.
Yes,
Okay.
you are right. Yes.
Okay. Thank you.
Yeah, you're welcome. Okay, so let's see how many of you have given response. 6 of you.
So could we have some more time?
Yes, sure.
Excuse me, sir.
Yes.
Sir, what I should enter when if there is no local minimum value?
You are not getting any local minimum value.
No, sir.
Okay. Okay. So maybe do not enter anything then. If
No,
you
no,
enter
no.
0,
Oh,
it will be.
sorry, sir. Sorry, sir.
Yeah, check this. Like, how is that? You need some more time?
So 10
No.
seconds.
Yes,
Okay.
sir. Yes, just 30 seconds.
Okay, sure. So maybe we can discuss this at after a minute.
Done, sir.
Okay.
Yes, sir. Done.
Okay, nice. So we'll wait till 4:55 and then we can start this.
Done, sir.
Okay, nice.
Done, sir.
All right, good. So I can see like most of you have done. So 30 of you. So maybe Sridhar,
Yes, sir. I'm here.
done?
Yes, sir. I'm done.
Okay. So could you just tell me the approach, what you have done, how you have
Well,
done this?
Sir, I have differentiated this x4 minus 10x cube. Double differentiated it, and
Okay. You first
I
found first derivative. First
sir,
you have
first
differentiated.
derivative is this hint.
Okay. Got it.
So
So from
I
here
got the
you get,
critical points.
okay, you got 4 critical points.
Yes, sir.
Okay. Then
And
you have
then
to,
after
then
I double differentiate this again, and I started putting the values one by one.
you differentiated it second time and then you substituted this critical point values, right?
Yes, sir. Yes, sir.
Okay. So you would have got some lesser than
at
0 and
x,
greater than 0 conditions,
yes,
right?
sir. At x equal to 2, I am getting greater than 0.
Yes, yes.
Okay, so you are getting basically like that. Okay, fine. And so then what you do? Then what did you do?
I put the x is equal to 2 in fx.
In f of x, okay, and then you
Yes.
got some values.
Yes, sir.
Okay, all right. So that is one way of doing. Do any of you have any other approach? Anybody?
I tried with the graph, first derivative graph, but I couldn't.
Okay, fine. So at least somebody is there with graph.
I tried, but I'm not able to get.
Okay, no
The
problem. Not a
graph is
problem.
much easier. Can you explain even that?
Yes,
more?
yes, sure.
Yeah.
Sure. Good that you're sticking on to that part. So nice. Yes, somebody is telling something. So okay, let's see what are the popular responses for this.
Sir,
So the answer.
I can do this with graph also, sir.
Okay, so just a minute. So most of you are telling answer as 7. I don't know why. Right. So the
So do we
answer.
have to substitute the minima?
You have to
value
find the
inside?
local minimum value. Okay. You have to find out local minimum value. Okay.
So it should
But
be.
most.
So should it? So sorry. Should it be from 1, 2, 3, 4? One of them.
So those are, that is not a value, right? It's the place where that value lies. This is
So
what
we
it
have to
indicates.
substitute this in the initial equation.
In f of x, yes, and then get the
Yes,
value.
Okay.
Okay, so let's see this. So yes, so this is what we get. I don't know, like if you can see what is written at the bottom. So it's okay. Let's see that. So at bottom it's written 7.46. Okay, so that's the popular. That's the answer for this. So, but most of you have given answer as 7. So I think some here and there, but certainly I think you got some nearby answer definitely. So okay. So most of you have given this answer, and one way of doing is I will just tell you here itself. Then we can go with that other part. So what is the thing what we should do here is, so our standard way, f of x is given. Since they are asking us to find out what is the local minimum value, right? So what you should do here is you should first find the first derivative, right? So when you find the first derivative, after finding the first derivative, you equate to 0, right? You find the slope equal to 0. And why do you equate to 0? Because you know that at critical points the slopes are 0, isn't it? That's why you equate to 0, isn't it? So that's what you do, and then you find out the x values. Then after finding the first derivative, you would have seen you arrive at this hint part, isn't it? So basically this complex equation can be written in this as well. So x minus 1, x minus 2, x minus 3, x minus 4, and then you can equate to 0, and then you can get your critical points, which is nothing but 1, 2, 3, 4. But now you have to understand, now that can be the point of minima or the maxima, right? This x value. So you will have to understand that where do you get that, right? So you should do the second derivative test. So you do that f double dash of x. So which equation should you use that time? You should be using this equation, right? So you find that f double dash of x, then substitute for 1, 2, 3, and 4, and you see where you get this f double dash of x being greater than 0. So wherever it be is greater than 0, that will be your local minima, point. So basically local minima, right? And whatever the point you get, so certain you will get 2 points where it is getting local minima condition. Okay, so when you substitute these 2 points to your main equation, you get 2 different values. Okay, so I guess this is what it's happening. So you get 2 different values. So whichever is the least one, that should be given as the answer. I guess there are 2 values. Let's see if there are 2. Yes, there are 2 minimum values you get. So that's what that is what you should do. So this is the standard way of doing it. The other way you can do is you first found the first derivative test and you got this 1, 2, 3, 4. Now let's understand with the graph what we can do. Okay, so now you see this, you got this graph. Since you got this first derivative, let me first take you to the graph what is been mentioned here. So here, see, in this graph it says that this basically this blue color, not blue color, the black colored, this black colored line curve what you see, this is your f of x, and this blue color line what you see is f double dash of x. Okay. So now you see from this graph itself, then we'll come to this part. Okay. So you see that.
Can you please explain how to draw the graph if derivative is given?
Right. See what
The blue color one
Sir,
is
the
the
blue
f
color
dash
is
of
double
x.
dash of x or f dash
The
x.
blue color is f dash
not
of
f
x.
double dash. You don't
Can
have
you
graph
please
for f
try
double
to
dash.
sketch? Can you please try to sketch and teach us?
Okay. See, first of all, drawing the graph for f of x is a difficult task, right? You understand this, right?
Yes, sir.
This is something we do not
Yes.
expect you to do, but
Now
certainly
we
you can
know
do
the
the graph.
derivative. We have the graph of derivative.
Yes.
By knowing the slope, how to point the maximum and minimum.
Okay, I'll tell you that. That's what I was explaining you here.
But the first derivative is a blue color graph.
The first derivative is the blue color graph, and this black thing you see is your f of x graph. Okay. So you see from this graph what is happening. See, from this graph, what you see is, of course, this blue, see, I'll tell you again, here this black color thing is f of x graph, okay, which is something you don't know to draw the graph, neither I can do, or like, I don't think so any of us can do without any computing tools, right? So this is something I don't expect you to do, right? And even I don't know how to do, so leave that aside, right? So, but we know something to do, right? So we can do the graph for this part, x minus 1, x minus 2, x minus 3, and x minus 4. Can we do the graph for this?
Yes.
Yes, sir.
Can we?
Yes, sir. Yes, sir.
We can do this, right?
Yes.
So when you do the graphing, so how is this? Can you tell me what is the leading coefficient?
It's
4.
It's 4 positive.
Oh, sorry, not 4, but it's positive.
It's positive. A is greater than 0.
What is its degree? And it's greater than 0. Then certainly
Yeah, even
both the
degree,
end
yeah.
points will
Even
be on the
degree.
same side. So you
Same
see
side.
the endings are on the same side.
Yes.
So what naturally we would have done is, so this is basically
1,
1,
2,
2,
3, 4.
3, 4. What
Four.
if I have to draw the graph, what I would have done? I would have drawn a straight line from here and a straight line from here, but I'll make sure this endings are on the same side, right? And then I would have joined them up, and I got the graph for this. So those, if you, I don't know, if you can do with the first derivative and second derivative, it's perfectly fine, no problem. This is some additional thing which I'm telling you. If you're not getting it, just leave it. But if you can understand, it's good. So what I'm trying to say here is, I'm just trying to give you an understanding, like what is this correlation between f of x and f dash of x, right? F dash of x is slope, certainly that is slope. But what is the correlation? What do we understand with this when we graph both of them, right? So let's understand this thing here. So now you see this f of x graph is drawn, right? And f of x graph is drawn, this black color thing, and this blue or purple color thing is nothing but your f dash of x, basically the slope graph. Now you tell me at this point, this is your f of x. What will be the slope value? Here, you can see my cursor, right?
0.
If this is your slope, then where should that lie? Here, right? From here, you say the slope will be 0, and this blue color thing represents the slope of this graph, then certainly this will be at 0.
Yes, yes,
Right?
sir.
Now look
But
at this.
I am unable to judge whether it is maximum or minimum. The bump will go up or down at the 0.
I'll come to that. Let me finish this. I know
Okay.
you are definitely waiting for that. I'll come to that. So now you see this, which are the other critical points? This one, right? This is like minimum condition, isn't it? So now over here
Yes,
as
sir.
well, what will be the slope? Slope will be 0. Now you see again, since this purple color line represents the slope, right? So what is the slope
Yes,
value?
sir.
0.
Yes, sir. The critical
Similarly,
point
at
of
this,
f dash x is the slope of f double dash.
so even for this, the
Is
slope is 0. Even for this, the slope is 0. Okay, now understand this. Now this slope part is done. That means if I can draw the graph for this, I can clearly say that, okay, these are my, that is what it means. Whenever it is 0, for whichever value it is 0, at that point, you will see the critical points of f of x, right? Clear?
Yes, sir.
As if now clear. Now, how do we get this is the slope? Now, how do we get this is the point of local minima or local maxima, right? How do we understand this? Now, could you tell me, look at this, I'll explain you this, then I'll take you to the slope part. Okay, now look at this part. Okay, as you are coming from left hand side,
Slope is decreasing.
Okay, let me finish this, then I'll take up doubt. What is happening here? Slope is what?
It is decreasing and becoming negative.
Okay, so you are going from negative hand side to positive hand. I mean, you are coming from left hand side to right hand side around this interval, around this point. Okay, so when you are coming from this side to this side, right? I hope I'm clear. When you are coming from left hand side to right hand side, what is happening? The slope is increasing or decreasing?
Slope is decreasing.
Decreasing and then decreasing.
No, no, no.
No. It
Only
is
thing,
Slope
only
is
one thing is
decreasing,
happening.
constantly
Decreasing.
decreasing.
Yes,
You
sir.
see that the slope at here,
Yeah, so
at
slope is
at
decreasing.
here
Yes.
is maximum, and then it slowly decreases and goes to 0, and
This
then
is
it attains the
confusing.
negative value, right? So
Yes.
slope
Yes.
overall, what is happening to your slope?
Decreasing.
Decreasing. That means
Decreasing.
can I say that
Yes.
at local maxima my slope or around that interval is decreasing? Can I
Yes.
generalize this?
Yes.
I
Yes,
can
sir.
generalize this.
Yes, sir.
Similarly,
It's
at
decreasing.
local minima, what will be happening?
It's
The slope
increasing.
is
Slope
increasing
will increase.
because you see this is negative value, and then it becomes 0, and then it increases. So around
Yes, sir.
this local interval, around this local minima value, what is happening to your slope? In that interval, it is increasing. So when it is, now I'll just summarize it, then I will come to the second part. Okay, so now you see this, when you have f of x at the point of local maxima, your slope in at the point or around the point of your local maxima, the slope is decreasing, and at around the point of local minima, right, the slope is increasing. Right,
Increasing.
now we are clear with this. Now look at this part. Now we are coming to this purple line. This purple line is the slope graph, isn't it?
Yes.
Now we know this is basically our what? This is our local minima point. Sorry, local maxima point. So at local maxima, what is happening to the slope around that point? It's decreasing. Decreasing around that point, it is decreasing. Now come to this. Now here it is being 0. Now come from this side to this side. What is happening to your slope? It's increasing or decreasing?
Decreasing, sir.
Decreasing.
Decreasing. Slope is negative.
Okay, is it clear?
Yes, yes.
Okay, now this is your minima point.
So just now, was it increasing or decreasing?
Here.
Yes, sir.
Okay, could you tell me what is happening around here?
So it's decreasing.
Decreasing. So look at this part. What is happening around here?
It
This
will
is also
increase, right?
it is decreasing only. It is decreasing. See what happens is, now if I have to just show you that, I'll tell you. So you look at this around that. What is that happening? I can just draw this. Just give me a minute.
Sure, sir.
So look at this part. This is what happening, right? And then this is something you get, right? Something like this. This is what you are getting here.
Yes, sir.
Yeah, and then it goes around. Now look at this. What I am claiming over here around this point. Now I know that my curve was something like this. It was point of, it was giving me local maxima, right? Around this, the slope should what? Slope should decrease.
Yes, sir.
Slope is decreasing, right? And I'm claiming that even here it should decrease because this is a slope curve, right? So look at this. What is happening? Slope over here. Now this is very steep, which is not perfectly right. Over here, the slope will be maximum. Over here, the slope will be still lesser, right? So sorry, this is more negative. If you to see this is more negative over here. This is, hello?
Yes, sir.
Just give me a minute. Just give me a minute.
So we cannot hear you. I think you're on mute.
No, he's coming back.
Okay.
Yeah. Am I audible?
Yes, sir.
Yes, sir.
Okay. So now you see this. What is happening around this point? Can you tell me what is happening to your slope around
So
this point?
my doubt is on
Okay.
on in the top one, we're looking at the whole curve, right? The turning point. But below that, we're not looking at the turning point.
See, basically, I was talking about the slope around this point, right? Around this point.
Yes, sir.
So you see, this is basically a local maxima point, right? Local maximum point. So what is happening to your slope? Slope over here, it was, since this is positive, this is also positive, this is also positive. This is what all possible slopes I can make, right? So you see, this is a larger slope value. This is larger. This is smaller than this, and this is still lesser than this and lesser than this. And eventually, what is happening is your slope is decreasing around this point, isn't it?
Yes, sir. Then it
Likewise,
becomes
you can make the same conclusion over here at this interval. Now, what is the value? You have to look at the value for this, not the slope for the slope itself. Okay. So basically, what you should look at this is what is the value at this point. Now, I'll take this interval. What is happening to the value of this curve?
the value will be decreasing.
The value is decreasing, isn't it? And this value is nothing but slope value.
So value of tangent or
Value of tangent. Value of tangent. Now, this curve is basically the tangent curve, right?
So it is the y value that we're looking at.
Yes, it is the y value which you are looking at. So could you tell me what is happening to your y values over here?
So it's decreasing.
It's decreasing, right? So that is what you will have to understand. Did any of you understood here? Or you have confusion?
Sir, confusion regarding increasing and decreasing.
Okay, so I'll explain this here in the graphically here. So now you understand this. What is happening?
Can you try to sketch derivative?
Sure.
And from that, can you derive the function?
Sure.
And also the values, how we are reducing the values.
Okay, sure, we can do this.
Draw the derivative function. From there, you
Sure.
teach us how.
Look at this curve. Maybe I am doing some another curve. Okay. Consider this as another curve. This is a critical point. This is also a critical point. This is also a critical point, right? This is also a critical point. This is also a critical point. This is also a critical point. How many critical points do we have here? 1, 2, 3, 4, 5, 6. So okay, let's consider this is our f of x. Now, if I have to draw the f dash of x, how will that f dash of x curve look like? So how will that curve look like?
Local maxima,
So wherever
local...
over here it will be 0. Certainly over here it will be 0. Over here also it will be 0. Let's say this is 1, 2, 3. Let's say this is 4. Okay. Let's say this is 5, and let's say this is 6. Right. So what will happen to your curve is it will change accordingly. Right. So
yes.
Right. It will change accordingly. But I'm very sure that over here it will be 0. Right.
Yes.
Right. So I must have some functions over here. So we can actually restrict to what it was given there. Now see what is happening, or maybe if I have to take this, I should take f double dash of x. So okay, let's keep it like this only. Now you tell me what is happening around this slope. Now we understood that if this is a local minima, if this is a local minima point, what is happening around the slope? Local maxima, then what is happening around that?
The slope is decreasing.
Slope is decreasing.
Yes, sir.
Around this interval.
Increasing.
Increasing.
No. I'm talking about this. Around this interval, slope is decreasing throughout, right?
Yeah,
no confusion till here. All of you?
No, sir.
All of you? Any confusion till here?
No confusion.
No confusion. Now come to this part. Over here, since this is a minima point, right? So around this interval, what is happening to the slope?
Slope is increasing.
Slope is increasing. Over here, again it will increase.
Sir, fast decreasing, then increasing, no?
Sorry.
Third decreasing, yes.
Sorry, what? No. It is decreasing throughout the interval here. Now you see this. Why I'm telling you that is, that's why I asked you, what is the slope value at this point? Can you tell me what is the slope value? It will be some positive value. Look at this. When I come to this part, what is the slope value? It is going to be something like this. Which has got higher slope, this one or this one?
First one.
First one, sir.
I'll take this to interval. Okay. Let's say this is L1, L2. And let's say this is f of L1 and this is f of L2, which has got higher slope. F of L1 has the higher slope. So as you are going this direction, right?
Yes.
As this is increasing, x value is increasing, what is happening to your slope? Slope is decreasing. And certainly when you come over here, the slope will be 0, and then later on it will become negative.
Yeah.
Right?
Okay, sir.
Overall, in this interval, what is happening to your slope as you move from left to right?
That means gradually it is decreasing. That's why we take slope.
Yes. So over here in this interval, I can happily say that the slope of this function f of x in this interval is which interval? Around this local maxima point. The slope of f of x is decreasing. Similarly, when it is local minima, around the local minima point, what is happening to your slope? It is increasing. Over here, it is decreasing, increasing. Then what is happening over here? Decreasing. Here, increasing. So this is slope thing, right? Slope thing. Now you see this. This indicates slope. Now what am I saying? Now what am I saying here? The slope, what happens to your slope? This slope value is decreasing, right? Decreasing means it is coming from some larger value to a lesser value, right? So it must be going something like this.
Yes, sir.
Because see here whatever you get these values, you will have to look at the values for this, not the slope for this. Okay, what is happening to the values for this? The value over here is some positive value, let's say 5. Over here it is 0. Over here what is happening? Some minus 5. So what is happening to your value? It is decreasing or increasing as you are approaching, as you are going to positive infinity side? Decreasing. So can I say the curve might go like this? And look at this part. What is happening over here? The slope should increase. That means it should go something like this. Isn't it?
Yes.
Yes, sir.
Over here, like this. Over here, like this. Over here, like this. Over here, like this.
Increasing.
Right. So now it is clear.
Yes, sir.
Okay. So now you can join this. You can practice more. But I think, is this too much?
No, sir. It is really
It's
enlightening.
it's so easy, sir.
Perfectly
very easy. Only issue is how do we, after making this
Okay,
graph,
now
how do we
I'll tell
find
you
the
how to.
local minima?
Okay,
Or-
now we will understand this. This also will understand this. Now we understood what is happening for the slope, isn't it? So first, what we should keep it in our mind is around the local. If we understood this, then we can certainly tell something about the slopes. Now, what are we telling here is at when it is, so just to tell you that around the local maxima point, or around the local maxima, the slope is decreasing, right? Slope of that function is decreasing, and around the local minima point, the slope is increasing. Okay, so just keep that in your mind, and when you draw the slope curve, right? When you draw the slope curve, you will follow the same conditions, right? So I hope that is okay. Now, if that is okay, then what insights we can get from here? Okay. So now look at the question what we have, okay? I mean, just simply drawing the graph and but not arriving at the answer is of no use, right? If you can draw the graph, then if you arrive at answer, then you will appreciate graphing also, isn't it? So now let's see how we can appreciate that. Now look at this question. Here we got this 1, 2, 3, 4. All right. So now, and since the hint was very clear, f dash of x is something like this, then you get some graph like this. Now, if you can draw the graph for x minus 1, x minus 2, x minus 3, and x minus 4, I will draw the graph for this. So let's do this graph and then understand this. Oh, sorry. So what is happening for this one? So you have been given function is 1, 2, 3, 4, and your f of x is nothing but x minus 1, x minus 2, x minus 3, and x minus 4, right? This is what your f dash of x is, isn't it?
Yes.
Right? So now if I have to draw the graph, we all are smart now. It's very easy to draw the graph. Why? Because I know the endings will be lying on the same side. Why am I saying this?
Leading
Because
coefficient
it's
is
an
positive.
even degree.
Leading coefficient is positive, and it is an even degree.
Positive and
Yes,
even
sir,
degree.
even degree.
Yes. So now that is why this is happening. But what about this inner region? So we see its multiplicities, right? For each of these, it is linear, so it will cross in a linear fashion. So here, over here, it will cross in a linear fashion. It goes like this. It will again cross here in the linear fashion. It goes like this, and then you get this, right? So we drew the graph for this f dash of x. Now you tell me what is happening around this point. What we were doing was we were actually doing f dash of x, right? To find out whether this point was local minima or local maxima, right? But how do we understand? No, just let me complete this. But how do we understand this? Whether this without doing f double dash of x. This is just an additional information. If you want to learn, you can learn this. Else you can skip this. You can do your f double derivatives. But what you can learn from here is that why do you do this f double derivative? Just to understand whether it is a point of minima or maxima, correct?
Yes.
Okay.
Yes.
Could you tell me what is happening around this of this
Yes.
function? Is it decreasing?
Slope is decreasing.
Yes,
So
sir.
Slope is decreasing. Is this point of minima or maxima?
Maxima.
Maxima.
Maxima. What about this?
Minima.
Minima, sir.
Minima. What about this?
Maxima.
Maxima, minima. So we got to know that these are the point of maxima, that is 1 and 2 are the point of maxima, and
Maximum,
2 and 4 are the points of minima. So I didn't have to do this f
Do
double
the second
derivative.
derivative.
Yes,
So
sir.
You
easy.
don't have to do.
Yeah,
Now
it's
if you can get this, okay. So now if you can get these 2 points from the graph. So we did not do this f double dash of x, right? And we did not substitute the value also in this f double dash of x, right? Just from the graph we got to know. Okay, now what we have to do is we have to find the minimum value. So it's just this and this value you substitute and get the value, right? So you see, when we are doing f double derivative test, you first have to substitute the value for x and get the value, right? But when you can do the graph for this, you don't really have to worry about anything, right?
Sir.
From the graph, you can tell, okay, this is the point of minima and this is the point of maxima. Clear?
Excuse me, sir. Sir, is it valid for discontinuous function also?
Huh?
If the
No. Again, for that thing, it is different cases. For discontinuous function, if you can draw the graph, then perfectly fine, right?
Okay.
You can do that all things. You can do, certainly. But again, you have to do the graph for this. Okay, so now I'll mute all. I'll just mute all and then you can unmute it. Yes, go ahead.
Sir, I had a doubt on the other page.
The previous one?
Sir, on your workbook.
Okay.
Sir, my confusion was that the graph that we that you've drawn below and the one that we drew above.
Forget about this. Forget about this. This is some random example which I took. Okay, this is something which we are doing with the.
I thought it should be the same. That's why.
No. It is not the same because you see there are so many critical points here. There were 6, but in your
this
question,
is just an example.
Different. Just an example, and ideally we drew the graph for the slope of this function also. But anyway, I'll leave it. Yeah. Okay. So this is something else. So do not get confused.
Can we generalize
so I think,
it?
See, what all things. Yes, you can definitely do this. You can generalize this. You can always do that. So now you see what was the benefit from this graphing was you did not do this f double derivative test, right? From the graph, you drew the graph. Now see, if you know to draw the graph, it's like a minute. In a minute, you can do the graph, right? Can you do or not? I mean, if you are with in my sessions from previous, you can certainly do this graph in some 30 seconds also, right? You can do this graph and you can make an analysis. Okay, yeah, this is what is happening over here. The values is decreasing. If the values is decreasing, actually the slope value is decreasing. If the slope value is decreasing, then can I say this point is the point of minima or the maxima?
Can we say when slope is negative, it's maximum?
Maximum.
Sorry?
Can we say when slope is negative, it's maximum point, and when slope is positive, it's minimum
Slope
point?
of what? Slope of f of x?
Derivative.
First derivative, okay. So
Yes.
first derivative, what you get?
Yes.
When the slope is negative, it is the local maximum.
When it is
At the
decreasing,
zero,
it
at
is
zero.
maximum.
At the root.
When you draw the graph of first derivative, then you can say that.
Then you can make things. Yeah.
Here
Then you
itself
can-
we can find out.
Sir,
So we won't be able to generalize that whenever it is negative, it is maxima, right?
You cannot say negative and all. That's why I was
Yeah.
hesitating to tell this. I mean, I was
So we
thinking
have to
whether
draw
we
the
can
graph to understand this.
Yes,
better.
you will have to draw the
Actually,
graph. and
we have to decrease. If you
Yeah,
decrease, it's
yes, that is
maximum.
the right thing you can actually say.
Increase, it is minima. Decrease,
Yes.
maxima. Increase,
Yes,
it,
thanks.
yeah.
Yes.
Maybe we can say, I don't know if this is right, that it's a local maxima if after crossing the x-axis it becomes negative.
How about why we want to get into all that? We'll just take some interval and say, okay, in this interval, whether it is the value is decreasing or not, right? If it is decreasing, then that is a point of maxima, right? In
Sir,
that,
if it is decreasing, that means it is getting negative. So it's also correct. What they're saying is.
okay, so in that sense you can say, but what we thought was, I mean, what I thought was it is some negative value.
No, they're saying because it is decreasing, it will be obviously negative.
So, okay. I mean, up to our understanding, if you want to take it that way, certainly you can do that.
One question.
So,
how do we know which value we have been asked about? In this case, there was two minimum, right?
Right.
F of 2 and
Correct.
F of 4. How do we know which one?
Correct. There were two values, this one and this two. So now you got two values, just substitute those two values in your main function. That is the only thing you can do. Okay. I mean, that is the only thing you can do. You cannot do much. With graphings, you cannot get the exact values, but you can actually get the nature of it. That is something you can do with the graph. But from graph, what you can, from graphings, you cannot get the exact values because we are doing a rough graph. We cannot get the exact values, right? So anyhow, so when you got these two critical points, local minima point, all you have to do was just substitute those value to your main function f of x here and get the value. So see, you saw that at 2 and at 4, you were getting, those were the points of minima, right? Those were the points of minima, isn't it? At 2
so
and 4.
we avoided the global minima and we chose the local minima, right? Am I right?
Correct. So in your main answer, you gave the global minimum value, global local minimum value. I mean, yeah, a global minimum value to be precise. Okay. I hope that is okay.
Yes.
Okay, so if you,
Yes.
I'm clear on this. So if you did not understood, just rewatch this, that graphing part at least. I mean, it can help you in some way.
Very useful, sir. Very nicely explained, sir.
Okay.
We can quickly finish this question.
Thank you.
Okay, nice. All right, so let's go to the next question, question number 5, and then we have one more, and then I think this will be like first time we'll be finishing our some session in 2 hours, but I don't think so. You will be going very soon because after this I'll be explaining you something more. So you will have to stay with me, or if you want, you can leave because officially, like once the slides are done, you can leave. Though we have
only 17 slides.
I have one question. I'll ask later.
Sure. We can do it at the end. So let's stick on to our things, what we are doing at right now. So somebody, now let's go with some Riemann sum kind of things. So you have question number 5. You have been asked f of x is something like this, and you have been given interval here. Now you have to estimate the area by dividing them into 3 subintervals of equal lengths. Now see, it says equal length. Okay, so be particular about this. And then it is been told that you have to use left end points for subintervals for the heights of the rectangles, right? So that also clearly indicates here. And then you can give me the rough area value. So see, most of us, I would tell you the normal tendency of the students who have just come out of the 12th, okay? What they will do is, okay, they must be not interested in Riemann sum and all. They know the integral thing and they are like, they'll be at very par at this. So what they'll do is they'll just simply integrate the value and they'll take the limits from 0 to 6 and then substitute the value and get. But the Riemann value will be different. Riemann sum value will be different. It will be slightly lesser than that.
No, I'm trying integral only now.
Yeah. So whatever value you will get, right, that value will be slightly more than the Riemann sum value.
So, sir, we can't do this in the exam, like integral.
You cannot do this, and we will certainly catch you there. we'll actually find the actual integral values and give one of the options. Okay. Or we'll give you some nearby values.
Here, n is going to be 3.
N is going to be 3. Okay, so it depends when you're taking x as
3 subintervals.
Yeah, so if you have 3 subintervals, so you will have 4 these things. So it will start with 0,
then 2, then 4,
then 2, 4, and
and
then
6.
6. Yeah.
6,
So
yeah.
then you will have 3 7.
Thank you.
Sir, excuse me. Is there any way to find the subintervals? Can you repeat the formula?
See, one way is like sometimes we give you some formulas, sometimes you would have seen it in your activities and in your assignment, practice assignment, where we mention that the interval goes with 2i by n, right? Something like this, or I by n, or something like this we mentioned, right? When n going to some values. But over here, it's very straightforward, not in that complicated sense. But here what we say is, this is your interval 0 to 6, right? You have to divide this interval of equal length in 3 intervals. Simple English thing you have to follow. That's all. You didn't get it, right? Is it?
Okay, sir. Okay.
Just simple English thing you follow here.
Okay.
Yeah. So do you need some more time or?
Yes, sir.
Okay.
Yes, sir, I'm done.
You're done. Good. So you can take 2 minutes.
Done, sir.
Okay, good. So we can start that.
Yeah.
So,
Yes, sir.
so I'll mute all, and then any of you can raise your hand, and then we can discuss. Anybody? Who's this? Okay, Anjana Kumari.
Yes, sir.
Yeah, hi. So yeah,
Yeah.
let's start. So what is your approach for doing this?
So actually, I found out the interval first. So the intervals are 0 to 4, 6. And then I started taking the value of f of 0, f of 2, and f of 4. Since I have to consider only left 10 points, so I didn't take out the value of f of 6. And then I took the summation of f of 0, f of 2, f of 4.
Yes.
And it came out to 87.
Okay. Okay, so that's perfectly fine. So let's see what are the popular answer. 574. What did you get the answer?
I got
574.
574
0.01.
something, some nearby, right? So
Yeah,
I think
point
all of
something.
you are very good with this. So Riemann sum, the main formula is this. So
Yes.
Riemann sum is summation I equals to n. Usually what happens is when you see this complex thing, then you read a line and second line and then we get lost, right? So what you should do is basically stick on to what actually it is and then go back, like back trace it. So Riemann sum is summation I to n f of xi star delta xi, right? So what is delta xi then? Delta xi is nothing but xi minus 1. So it's basically the next term minus the previous term. So whatever that difference is, that is your delta xi, and this xi star is nothing but in that interval, basically in xi minus 1 comma xi, you can take any interval, but in the question we are telling that you have to take the left hand limit. That means you have to take these values, right? So as she told, like the intervals are 0 to 2, 2 to 4, 4 to 6. So the left hand side values will be 0 to 4, and delta xi, since it is telling equal interval, right? So we took it in that way and we found that delta xi value is nothing but 2, right? So all we have to do is just substitute this value. Now f of 0. So what was your function? Function is 46x plus 22 by 6, right? So all you have to do is just substitute these values for x. So when x is 0, so what do you get? 22 by 6 times 2. So that turns out to be 7.33, some decimal values. Similarly, when you do for f of 2, times 2. Why are you doing this times 2? It's because this is delta xi, right? And you have to repeat this until you reach your n value, and your n is nothing but 3.
Which is the area of the rectangle, sir.
Yeah, right. So you will get basically 3 rectangles, isn't it? So you get 3 rectangles, and then you find the area of those 3 rectangles, and then you happen to see that this is what you get, right? So you see, when you do this Riemann sum is nothing but this sum of all these 3 rectangles, or like how much, like whatever, like when we say there are n rectangles, then you can actually do for n rectangles and then get the values. So Riemann sum is basically the sum of them. So when you add them, you get some 574 values.
Sir, I have one doubt, sir.
Okay.
Sir, if I divide the interval into n parts,
okay,
sir, then what will be the xi?
Delta xi?
No, sir.
Could you tell me what will happen?
Delta xi not, sir. Delta xi, sir.
Okay, could you tell me what will be the xi value?
Sir, delta xi will be 6 upon n.
You see that what happens is your difference will become the same value itself.
6 minus 0, 6 divided by 3.
Yeah.
But I'm talking about n divisions.
So when you see that,
x upon n.
So when you do that x upon n, so it's basically delta x upon n, right? So you take that 2 difference value upon n, and now you're telling that n tends to infinity, right? This is what you're telling, no? Your n is very large.
Yes, sir.
When n is very large, what is happening to your delta? What is happening to your delta xi value?
Delta xi value is becoming 0.
Yeah, it's tending to 0.
Yes,
right?
Sir. Yes.
So similarly, then what you should take that value, since your xi star belongs to this delta xi, right?
Xi star, sir.
Xi star, see here, xi star belongs to this, no? In this only, right?
Sir, I am taking left Riemann sum. So xi star will be equal to xi minus 1.
Right.
Yes,
okay.
Sir.
So in that case, what will be the value for you, this thing? So of course, essentially, it's going to be the one which is, on the left hand side, right?
Yes.
Right.
So how will you find xi minus 1? I'm not able to solve this type of question, sir. When I am dividing n times into n parts.
See what I'm trying to say here is, when you are taking your when n is infinity, what is happening to your x I minus 1 comma xi? What is the value of these two? It is going to be very minimal, right? When you take the difference of it, it is going to be very minimal, right?
Yes, sir. Yes,
At
sir.
that point of time, can you even segregate what is your left hand side and what is your right hand side? I mean, right, you cannot do it. You will take a single value at that point of time, isn't it?
Yes, sir. But
I hope.
what will be the exact value of xi minus 1?
Okay, could you tell me what is the exact value of infinity? It is the same question you are asking me here.
Sir, I'm not getting it, sir, actually.
See, I'll tell you what you are trying to say is when you are finding, when you are saying when n tends to infinity, that means there are infinitely n rectangles. So you
Yes,
are
sir.
saying basically there are n rectangles, your n tends to infinity, right? So can you imagine, can you think of how many rectangles do you have? You will have so many rectangles. And
Yes,
now into that rectangles, now you are asking me to find out what will be the value of xi minus 1, right?
Yes, sir.
It's essentially is a straight line, right? If you see a vertical line, it's actually going to be a vertical line. So basically, you can actually represent that as a single value. I mean, you can say a natural number. You can actually substitute a natural number. That is what it means. You still not get? I'll tell you again. See, what is happening is basically, okay, maybe I can use this and explain you. Sorry. Let's say initially you had only 3 rectangles, okay, for your curve like this, right?
Okay, sir.
Are you here? Am I
Yes,
audible?
sir.
Yeah.
Yes,
So let's say
ma'am.
this is what you had. Now initially this is your value. Let's say this is 1, 2, 3, and 4. Okay.
Yes,
This is
sir.
your value. Now if I have to say that I have made from this, now I have made 6 rectangles, right? So what will be the value for this? This is going to be 1.5. This is going to be 2.5. This is going to be 3.5, right? So
Yes,
what
sir.
essentially you have done is now you have made 6 rectangles now. So what is happening to your n? N is increasing, right? So
Yes.
when n is increasing, look at your interval values. Now here, over here, what is your interval values?
Yes, sir. It will become small, sir.
It will become small. Now
Yeah.
you take another into this. Now I'll take just this. Now this is 1 and this is 1.5. Okay, now I've just taken this part. Now what happens? Now you are trying to do another rectangle. So this is going to be 1.25. Now what you are doing essentially is you are essentially increasing these rectangles itself. And what is happening to this value? This is tending towards what?
Yes, sir. Yes, sir. I got it, sir.
You got it? Okay.
Yes,
So
sir.
that's what I was trying to explain you that time. I guess I could not convey it properly that time.
Okay.
So sorry about it.
Thank you,
Yeah.
sir.
Yeah.
So do we
So,
always exclude the last value, like 6
no.
is
He was asking the left Riemann sum value, right? So that's why we were taking that.
Sir,
So when
what if
you're
the
doing
right?
that right hand side, no, when you're taking right Riemann sum,
yes.
in that case you will take 6, but you will not take 0.
Okay.
Okay.
Sir,
So
it means only
we
the
have,
last. Sir, it means only the last point we need to exclude. For example, if they say that left Riemann sum we need to take, so it is not only 0 to, like only the last element we should leave.
only the last value you should leave.
So similarly, as you said that if it is asking for the right one side, so
you
in
leave
that
the first value.
Yes.
Excuse me, sir.
Okay.
So,
Yes.
so we take the left hand limit, left hand Riemann sum,
Riemann sum, yes.
and Riemann sum. Which
Go
will
ahead.
be better approximation for which type of function?
Okay, that is you will have to really generalize it, right? So that is something we shouldn't do because it's really hard to do. We cannot even say a polynomial function and the best way for doing is left Riemann sum. We cannot do this because polynomial itself, some polynomial might be very steep, some might be very flat, some might be decreasing polynomial, right? So it is very hard to generalize, so we cannot say anything about it. That's why we have definite integrals.
Okay, sir. Okay.
Sir, if it is right, then how will take the
Then in that case you will
intervals?
leave the first value. You will
Means
take the
2,
same
4, and
interval.
6.
Yes, that is what you will do. Okay. So is it clear? Okay. Should we move?
Yes, sir. Yes, sir.
All right. Okay. So this is the another question which you have. If x minus y is equals to 1, find the least value of 2xy. Okay. So could you do this?
Sir, all these questions are from
Graded assignment.
Graded assignment.
Yeah. So essentially, this graded assignment is the easiest graded assignment, I feel, because
Yes, sir.
for 2 questions you don't have figure and you have only 9 questions. So essentially, you're left with 7 questions, out of which some 2-3 questions we discussed here, and now I'll take you to the slides and we'll discuss more. I mean, portal. So I think this should be the easiest one. And after this, you can actually focus on your quiz too.
Sir, when is the revision session, sir?
It's going to happen on Tuesday, most likely.
Okay, sir. Okay, sir.
Yeah.
Sir, they will take best of 2 quizzes, sir.
Yeah. Even if you write one, it's okay. We'll take just one.
Okay, sir.
Yeah. All right. So you need some more time.
So just
Okay, just start it. All right. So we can give you some 2 minutes. Okay. Do you need some more time?
No, sir.
Anybody else? Like, any more time? Okay. So I guess you don't need more time. So, okay. So if anybody would like to, okay, Anjana Kumari again, you want to answer this?
Yes, sir.
Okay.
So actually,
Or-
sir,
yeah.
So
Go ahead,
here
go ahead.
we'll first find out the value of y. So it would be x minus 1. And then we'll substitute that value into xy. So we'll get the equation as 2x square minus 2x. Now we'll take the first derivative of this and we'll get 4x minus 2 equal to 0. So x would be 1.5. And when we'll take the second derivative, we'll get 4. So which is 4 is greater than 0. So it's the local minima point. So it has the least value. So what we'll do then, we'll put this x equal to 1 by 2 into the equation that we have, and we'll get the value as minus 0.5.
Yeah, right. Yeah, so
I have used other concept, sir.
okay, what is that you have used?
AM greater than equal to GM.
AM greater than equal to GM. Okay, arithmetic mean and geometric mean.
Yes, sir.
Okay, that is also good. All right, so popular answer is 0. Oh, sorry, 1.25 minus 1.25.
Yeah, I got minus 0.5.
You
Yes,
got
me,
minus
me too,
0.5.
sir.
Okay, so let's see. Yeah, so the answer is minus 0.5. So to all, like if you still did not get it, what Anjana told, so I'll tell you again here. So x minus 1 is equals to 1, which implies you can write this as y is equals to x minus 1, just the way Anjana told it. Now what are we doing here is we are
Sir, we
substituting
can
this
solve
value.
this by quadratic equation also.
I solved it with quadratic only.
Yes,
Got
sir.
the vertex?
Yeah, nice. So yeah, now you know that so many things can be done, right? So good. So now you got this f of x is equals to this. Now one thing what you can do is you can find the quadratic and get the vertex like what the other people are telling. You can do that as well, or you can do the first derivative and second derivative test and get your values and then substitute. That's all. You get this minus 0.5. So do you have any doubt on this particular question?
Sir, the minus 0.5, how did you get? Just putting the value.
Just substitute the value, yeah. So since we are asking the value, right? So first we found out that at x we are getting this is at 0.5. That's the point of minimum. So that means at when we substitute this 0.5, we'll get the least value, right? So when you substitute this to your f of x, and your f of x was nothing but this thing, right? So when you substitute this value, you get minus
Okay,
0.
so sir, after getting the first derivative, when we're going for the second derivative, so then we got that it is greater than 0 and it is a point of minimum. After that, we just thought, okay, then 0.5 we need to put into the value.
Yeah.
If we were getting, let us say, negative, then we should get, should not put that value, right?
Negative?
Now we got f double prime x is greater than 0. Then we come to know that f prime x, that value we need to put into the equation. If it is less than 0, then we should not put that value, right?
No, even that in that case
Yeah,
also.
it would be point of maxima. Had it been less than 0, it would have been a point of maxima.
Yeah.
So we'll get the maximum value of 2xy in that case at
Yeah.
that point.
But you are asked the minimum value.
Yeah.
So maybe in that case, you won't get the minimum value then, right?
Yeah.
I mean, that would be like a downward parabola, right?
So we'll get the maximum value, right? In that.
Yeah, so you get the maximum value. So yes, so before, within 2 hours, we have completed our solve with us session. So those who want to leave can leave, or if you have doubt here on the graded assignment, we can take up these doubts. So maybe like, do you have any doubts? So maybe I'll take you to that portal and just will ask you some doubts. Then I have something to discuss to you. So you can wait for another some minutes, and it's like if you are there, it will be beneficial. So you can
So your
wait.
voice is breaking.
So could you tell me like
Sir, your
the
voice
first
is-
question is doable, right? You can see my screen. My voice is breaking. Okay.
So your
Okay.
voice was breaking just now.
Now it should be
We can see the
okay. So
screen,
now
sir, but your voice is lagging.
Yes.
is it still happening?
So it's okay now.
I have one question. What is the integration of mod x? Should we go for two different curves, less than 0
Two different
and then
curves.
one?
Two
Okay.
different curves. Yeah. Okay. So now what you do here is what first of all a function is given, then area under the curve is given, and then the graph is given. So one thing right, you're very good at graphing, so you can do the graph and understand okay which is matched with what, right? And another thing is finding the area, so you can apply some geometric properties also, or you can just simply do the integration and get the answer. And somebody asked me like, if it is modulus, then what should you do? You just split that modulus thing, right? When it is lesser than 0 and it is greater than 0, and then likewise find the derivative for this, you will get it. So this is something doable. This question, simple,
Yes, sir.
doable, right?
Yes, sir.
So no need to discuss.
Sir, please discuss question number 2.
Question number 2 we have to discuss. So maybe I'll take up a similar question and then I'll ask you to do. So that is something
R
we can.
square. Yeah. R square is we have a right angle triangle there, right? So we'll take that R square equal to H square plus X square. We'll get to know what exactly is the answer.
Okay. Yes.
We'll just
So
have
maybe,
to put the values.
yeah. So since these are given, you can just simply substitute and get the answer. So that is again doable. So, just that you can give a practice. Over here, which curve in the following
Yes,
figure
sir.
encloses the negative area? So negative area here means this
Yes, sir.
part, right? So this is what I was talking about, and I was telling you activity, it's not activity but graded. So you see, if this is maximum, so this area, what we are telling is negative area, okay? And this as the positive area. This is what simply we are telling it, okay?
Excuse me, sir.
Yes.
Sir, will you also take questions from practice assignment?
We'll see if we have time, but
okay.
So we have some.
what I thought was I discussed something.
So I do have
Sorry.
few questions from the practice.
So this is
assignment.
again very straightforward. You just have to see. Okay. So let's see if we have more time, we can discuss that. Okay. And this question, we did not give figures, so maybe we'll not be counting around anyways. That was 0 points. So that's okay.
Right.
But since we discussed here in the practice assignment, so it's okay. Okay. So again, it's a similar thing, right? So this is
The
5,
same
6.
question, yes.
This has also been discussed. We discussed this. This is also discussed. Right. Over here, what you have to do, you have to give the value or the x value or f of x value.
F of x value, sir, I think. Global minimum.
Global minimum. No.
Okay, could you tell me when we tell you what is global minima? When I tell you global minima, what value you would have given? X value or f of x value?
F of x.
No, sir. X value. X
You
value.
should actually give x value. Do not give f of x value and come. Okay. You
What
have to give x
Sai
value.
sir, could you
I have
repeat that?
given X value.
Can you
You should give
repeat,
x
sir?
value here. X
Okay.
values.
We have to give the x value.
Yes. Do not give f of x.
Okay, sir.
Okay, sir.
Right.
So then in which case do we give the f of x value?
When we tell you what is the global minimum value, then give the value. Otherwise, don't give it. This is similar of asking global minima. What is global minima? Right?
So this is x value.
Minima is a plural, right?
So this is x value, right?
X value. This question
on
is
which it is attaining global minimum.
Yes.
Yes.
At what x value? All right. So I think all these questions are doable. This question somebody is struggling, so you can actually give a practice. And similar question, if you have to ask me, I would refer my NCERT textbook of 12th standard. It's
Okay,
like
sir.
directly
Thank you,
given
sir.
from there. All right.
Sir, actually, I was also struggling initially, and then
With
I
this.
thought, but this is the easiest one.
So
Just have
those
to
who are
substitute
still
that.
yes, those who are still struggling, you can actually do it. You just have to substitute and then find the derivative. This is doable. Now I think you can do good with the graded assignment. Now I want to ask you some question. Okay.
Okay.
Yes.
So
So
I
can
had
I?
a doubt in like integral of uv.
Okay. Yeah. So we can take up here only. All right. So
Thank you,
just
sir.
give me a minute. Just give me a minute.
Sure, sir.
So like those who want to leave can leave because our session is done, but this will be essential if you know. So maybe I'll put some questions and then check your knowledge, like how much you know on week 9, because I could see like all other sessions went well and it was done very nicely, right? So we can just discuss some of the grave areas where I feel you can go wrong. So maybe I can just discuss those questions. Okay. Or like these are some conceptual questions which you should know, and like what we stand for. Okay, so maybe I can just give you a figure like this.
Sir, this part also will be recorded, right?
Yeah, it will be.
Okay, thank you.
Okay, now this is, let's say, some 5. This is at 2. This is happening. Okay, so could you tell me, is there a critical point for this function?
Yes, sir.
Okay, there is one critical point, right?
Sir. Yes, sir.
Okay. Could you tell me maybe Okay. So could you tell me what is maybe wait. I'll just try to do something more here. Consider this as 6. Okay, could you tell me what is the right way to ask this? This is happening, let's say at somewhere like 6, maybe. Yeah. All right. So for this particular thing, could you tell me?
Yeah, this is a critical point, sir.
So how many critical points are here?
3.
3.
1, 2, 3. 3 critical points. Okay, so that you can answer. Okay, so that is something I was expecting you can answer. Now let me see if you can answer this. How many global minima are there?
Global.
Or how many local minima are there?
2 local minima.
2, sir. 2.
Now you have added one more critical point, right?
I have added one more. Yes.
Two local.
2.
Sir, we are
One is
checking.
this and this.
Yeah, and
Right? And how many local maxima?
2.
1.
Oh, no, 1, sir. 1. Local maxima is 2.
2.
1 or 2?
Can
5
we
and
tell
6.
short fetches also as
5
local
and
maximum?
Yes, I
Yes,
think it
yes.
is undifferentiable.
So could you wait? I'm not done here. Just give me a minute. Okay. Now tell me how many local maxima are there here?
5 and 6. 1, 2.
2.
Local maxima.
2.
Where
And
all?
one.
Where all? Could you tell me where all?
5 is
5.
equal to
That
Sir, in the total graph, how many maxima?
How many maxima are there in this graph?
One,
Total?
sir.
Then
One or 2?
X is equal to 2 and X is equal to 6.
6 is the only local maximum.
Only 6.
I think 3.
You mean to say at 6? Only 6, right?
No,
Yes.
Only
5
6.
is also
Only
there.
at 6.
5
Yes,
also
only
there.
5.
5. This is minima, no? I'm asking local maxima.
2, sir. 5 and 6.
Yeah, 5 and 6.
Yes.
Where is 5? Okay. Here, you mean to say at
Yes, this is 5.
Yeah.
Then
The
5
value
when I'm
cannot.
telling local maxima, you should tell me this
Yes,
value,
sir.
not
5
the
and 6.
value. Right? Local maxima. What is the local maxima places? This one
2
also
and
is
2
it?
6.
and 6.
2 and 6.
2 and 6 are.
2 and the 6.
2
Yeah.
and 6.
Okay. I think then you know this. Then I don't have to explain this.
Sir, one question.
No,
No,
sir.
sir,
If you
please
explain,
explain.
then also
Please
good.
explain.
All right.
Yes. Sir,
Please go ahead.
like here, there is a discontinuity, it is not continuity there, no? So will we call this as also a maximum? Because I think only 6 point is the only one maximum.
So you see that you will have to stick on to the definition. That's why I was telling you. So since most of you already know, so I was thinking I can skip this, but some of you still have doubts, so maybe we can discuss this. You see that where is that? Yeah, here. Maybe not extrema, boundary point, critical points. So here, this is what we were talking, right? Global maxima and global minima, isn't it? This is what we were discussing. Rest all are easy, so don't worry about it. And I think you are already done with this.
Sir, do we have this document?
This note, can you please send us? It's very nice note.
Please, if you
This
can.
is there in your Solve With Us. It's there in Solve With Us.
No,
Sir, it is in the form of video, not as a
No, it
PDF.
is.
No, not
Yeah,
in the
we
video
need.
also. I
Explained
will
it
show you.
really well.
Here in the portal itself, you will see it.
No, sir, I couldn't find.
See, in your portal, there is written, no, Solve With Us. You will find this information and then you will have questions.
Sir, just now, how many maximas are there?
For which one?
Sir, just
can
now
you please
graph,
explain
how
that?
many
Because people are
maximas?
simply
So I
discussing
was
other
telling you,
things.
local
When once a
maxima are
doubt is
2
being
for that
discussed,
particular.
I don't know what the logical meaning of.
I'll tell you that. So you see that how many local maxima are there? So there are 2. Which is that?
Okay.
One is this and another is this.
Okay,
Okay.
Sir, can we take the boundary point also on the right?
No. You will not take that. So now, So if I have to tell you the definition, it says local maxima, right? So it says that C is called as a local maxima. So C here over means 2 and 6, right? That is what we are telling, 2 and 6. This is our C, isn't it? So C is called as local maxima if there is an h greater than 0 such that f of C is greater than equal to f of x. You see this, f of C is greater than or equal to f of x for all x. Look at this interval, C minus h comma C plus h. So maybe I'll take you here. Now what is the condition? That f of C should be greater than or equal to f of x for all x belonging to what? What was it?
C plus h.
Sorry, C minus h and C plus h, right?
Yes, sir.
So it was C minus h comma C plus h. Now this is the interval you will be taking. If in this interval, if this is increasing, so in other words, if you take this, if this is your C, then this is your C minus h, right? This is C minus h and this is your C plus h, correct? Correct, and this is your C. Am I clear on this?
Yes, sir.
Okay, so now you see this, whatever value you take in between them, your f of C is always greater, right? Now you see this, f of C is greater than or equal to f of C minus h. Is this right?
Yes.
Yes.
Is this right?
Yes, sir.
Yes, sir.
And f of
Is less than f of C plus h.
and again your f of C. Okay, my pen is not writing. Just give me a minute again. So again, your f of C is greater than or equals to f of C plus h, right? Is this also right?
Yes, sir.
Right?
Yes, sir.
So if this
Yes,
is
sir.
happening, I can say that C is my what? Local maximum.
No.
This is what it says. No, it is basically local maximum, right?
Yes,
So
sir.
C is basically understood. Now let's go to the other part. Look at this part. This is again your C, right? Now what is your C here? 2. Let's take some interval. Let's say some interval, some lesser than value. This is C minus h and this is C plus h. Now you see this, f of C is greater than f of C minus h. Is this right? Yes.
Yes.
F of C is greater than equal to f of C minus C plus h. Yes. Again, this is right. So this is fulfilling this condition of your what do you say, that local maxima, right?
Yes.
Local maximum.
Yes.
So this is again fulfilling that condition. So yes, that is. Sorry.
Sir, which one that f of C in the
F of C is this one.
at 6.6?
No. I'm here. I have reached here. This one we understood.
I am not able to.
Did I?
Yeah. So even though we.
Yes, please go ahead. Please go ahead.
Points you then you're comparing with f of C is greater than is equal to f of C minus h and C plus h. Similar, okay. Here, how is it exactly? I'm just not getting exactly. F of similar, the 0.6 you're telling on the y-axis.
At this I'm telling. At this I'm just
comparing that it is greater than that. I'm not getting that one.
Okay, now I will explain you this. Take this point. Okay. You can see my figure, right?
Yes, sir.
Now let's say this is happening at 2. Okay. Now let's stick on to our definition. What is our, here C is 2, right? Here C is 2 and this is C minus h and this is C plus h. And we are talking about local maximum, no?
So here we won't get.
We'll see whether if this definition suits in here. Now, sorry, the above one. So what is our f of C? Some values we are getting. Let's say it was not 5, or let's say it was some 5, right? So if this was 5, then if I have to take this, then this is slightly greater than 5, like
Yes, sir.
5.3.
Yes,
So
sir.
now you see that what is happening at f of c, I'm getting 5, right? But what is that f of c minus h giving me? Or
5.3.
let's go with this. Is f of c greater than or equal to f of c minus h?
No,
Is this
sir.
happening? This is not happening. So as per our definition, where is our definition? Here. The local maxima says what? F of c should be greater than or equals to f of x for all x in this interval, c minus h comma c plus h. So that is not happening. Therefore, over here, the local maxima does not exist, right? Local maxima does not exist here. But over here, the local maxima exists. Am I clear?
Yes.
Yes, sir.
Oh, sir,
Sir,
why local
actually,
maxima not
actually, sir, actually disconnected for a minute. I could not understand, sir, how we are comparing that f of c, that plus and minus is greater than that. Can you please repeat that one, please?
Okay. So now you understood this one. So we can say that local maxima condition is this, right? Local maxima condition is what? This one. F of c should be greater than or equal to f of x when x belongs to this. Clear?
So that f of c value, how much it is? Like, is it 6?
So when we are over here, when we are checking for this one, over here our c is 6. C is 6. Here c is equals to 6. Am I clear? Am I clear? Am I audible?
Yes, sir. Yes, sir.
Sir, so in this case, there is only one local maxima, right?
So there is only one local maxima here.
Sir, but initially we were saying there are two.
No. Here in this, is it? In this one. In this one, there are two. In this, there are two. But for this, in this, there are two only. Sorry. What I meant to, I was thinking about here. In this, there are two.
Sir, the first one doesn't satisfy the condition, right?
This one?
Yes, sir.
He was talking about the below graph.
I was talking about the below graph that time.
No, but even the top one, it doesn't satisfy, right? Because
It does.
C plus.
It does. You see, that's why to explain this, I took this graph to explain. So maybe I'll repeat it. again. So pay attention.
I got it. Both the sides are lesser than the top value.
That is what we meant here. So you see, what happens is whatever the C value, it has to be greater than in this particular interval.
Okay.
Right. So over here also, if I take this particular interval, you see f of C value is greater. But look at this interval, f of C value is this, right? But you have some values over here which is greater than this.
Correct.
Right. That is why here local maxima does not exist, isn't it?
Yes, sir.
But over here it exists.
Yes, sir. Got it.
Okay. So clear on this?
Yes, sir.
All right. So having known this, let's discuss one more thing.
Sir, I have a query. Can I ask? So global maxima and global minima always find only on the function when it is given the boundary, in the boundaries.
Need not be, right? You can have a function like this. This is your boundary. This is, let's say 2, 4, and let's say this. What is local maxima for this function?
3.
3. The boundary need not be always.
That is also
Again, the global maxima is not the same, right? Global maxima is again 3 in that case. What it means is when you are finding global maxima, right? When you find global maxima, what you do is, when you do this global maxima, what you do is you check at critical points, then you check at boundary points, and whichever gives you the highest value, that point become the global maxima. But you should also know that local maxima is also called global maxima, but when you say absolute, right? So at that point, the thing changes. Okay. Okay. So now, if that is okay, so now let's go with this. Now I have a graph for you. And this is like something last I want, this is something I want to discuss, and then one UV wala integration we can do, right? And then we can wind our session. So you see, we have a graph, something like this. Okay.
Yes, sir.
Okay. So we have a graph, something like this. Let's say these are some values. Let's say this is 2, 3. Let's say this is 7. And let's say this is something at 8. Let's say this value is 5. Let's say this value is, I mean, not exactly, but let's say this is some 3 maybe, or maybe this is, let's say, give it as 7. Okay. So let's say this is your f of x, and this f of x is defined in an interval. Could you tell me what is the interval where it is defined?
2 to 8.
2 to
8.
8 is included?
No, it is not included.
Okay.
8 is not.
Okay, so now I have some questions, and these are some clarifications. Okay, it's mostly like a clarifications. So could you tell me, just tell me, let's give it as A1, and let's call this as A2. Okay. Tell me, do limit for A1. I'll just do for A1 and then I'll do for A2. Okay. So this is more like a clarification, and also you can keep this as your knowledge base. Okay. So A1 is basically this point and A2 is this point. So tell me quickly, do limit exists at A1?
No, sir.
No, sir. No, sir.
No,
sir.
Is it continuous at A1? So maybe it is about A1. So we can just simply write limit exists at A1, continuous. It is continuous, or maybe we can say, is it continuous, differentiable, cannot, maybe I can just say that, cannot say anything about differentiation. Okay, so which among this is right? Do limit exist at A1?
Sir, if limit
Does
is
not exist.
given,
Limit is not continuous at A1.
So
Okay.
it's not continuous, and since it's the starting point of the graph, so we don't know about the left. We
But
cannot
don't know
calculate
about
the limit.
differentiation.
Cannot say anything about differentiation at A1.
Okay, so now I
No,
will
no,
tell
no,
you.
no, cannot. We can say if it's not continuous, then it won't be differentiable. But
No,
if-
differentiable then
Okay,
continuous.
okay. Now let's discuss this. First, I'll tell you what is the stance. Limit exists at A1. Okay.
Yes.
Okay. Why? Because you see, we cannot talk anything about left-hand limit. Can we talk anything about left-hand limit when the function is not defined? I cannot talk. So when I'm finding the limit for this continuous function, so at this boundary, I would say that the limit exists. And what will be the limit value? Just the value of that function. Okay, so you will just find the right hand limit over here. Am I clear? There is no concept of left hand limit coming at this boundary point. Is this okay?
But it is not continuous, no?
It is continuous as well.
If the limit exists, then it will be continuous.
If the limit exists,
in RHS won't
Continuity of both the limits are required, no?
no, see, that's what I was telling you. You look for continuity when in the defined domain, no? In the given domain, right? Here, this is the boundary point. Okay. So left hand limit concept will not come at all.
To confirm limit exists, left hand limit equals
So
to
domain means 2 and 8.
If
Your
it is a
domain is 2
boundary,
to
then
8.
do we check? Don't check
So this is
about
why
the
this is
left
a
hand or
special
right
case.
hand.
This is why this is a special case. When there is a boundary, so understand that when you are at boundary, there is at least left hand limit or right hand limit. We cannot talk anything about that. So over here at A1, can you talk anything about left hand limit? You cannot talk, right? You cannot talk anything about it. So forget about the existence of the limit.
Is there any special rule for boundaries, limits?
Yeah, this is what I'm telling right now.
Okay.
Okay, so is this okay?
Okay.
So at boundary, either left hand limit or right hand limit, we cannot talk anything about it. So at A1, I cannot talk about left hand limit. But do limit exist at that point? The answer is yes, because I can find the limit value just with the right hand limit. Okay, so the limit exists at it. So if the limit exists, can you tell me, is it continuous at A1?
Yes, sir. It's
Sir,
continuous.
yes, sir.
Yes, sir.
Because when you
Continuous.
substitute this 2, you get some value, and that value is nothing but equal to your limit value, so it is continuous. But we cannot talk anything about the differentiation, about the boundary thing. So just keep it in your mind. This is something, a debatable thing. So as of now, you can just keep this in your mind that at boundary, we cannot say whether it is differentiable or not differentiable. Okay, clear?
Okay, clear.
Okay. So just keep this in your mind that at A1, the limit exists. It is continuous when some condition is like this. And we cannot say anything about the differentiation. Clear?
So,
Okay, sir.
Yes, sir.
so,
Okay. Now let's go to A2.
sir,
Limit
Limit does
limit
not
exists,
exist.
not continuous.
Limit does not exist.
so for A1, I had it out.
Right. Left hand limit
Let's
exists.
finish with the A1. Yes, go ahead.
Sir,
Think. Do
if,
not talk.
if,
Yes. You tell me
if
what is your doubt in your A1.
sir, if limit exists, we can't say it is continuous, right? I said it the wrong.
No. I'm telling you, limit exists. That is okay. Limit exists. But if limit does not exist, I cannot talk anything about continuity. But
Sir,
now
but,
I'm sure.
Sir, in this case, how did you arrive at the function being continuous?
I'll tell you. First, we are convinced that the limit exists, right?
Yeah.
Right. So if the limit exists, then can you tell me what is the limit value at A1? 5?
Yes, sir.
5? Okay. So I can say that when limit x tends to 2, f of x is nothing but what? 5. What is f of 2? 5?
Yes, sir.
Now you understood, right? What is the condition for continuity? Limit should exist and the function value for that point should actually be equal to the limit value. Both are same. That's why it is continuous. Clear? Now
Yes,
come
sir.
to this. Now I think A1 is all cleared. What about A2? Limit exists?
Yes,
No,
sir.
sir.
Yes, limit exists.
Yes. Just
It's not continuous.
continuous.
It is not
Continuous.
continuous.
Yes, sir.
And
Cannot say anything about differentiation. If it
we
is
can-
not
we-
continuous,
we
we can
can say
actually say, we can say,
that
so
it's not differentiable.
this is not right, because we can say something about, because if it is not continuous, then definitely it is not differentiable.
Right, sir.
Yes. Yes,
Right?
sir.
So I can simply say this is differentiable. The answer is no, this is not differentiable at this place, right? But
Excuse
you
me.
understood that. Yes, tell me.
Can you explain why limit exists at A2?
Okay, you understood over here now the thing what we told, because we are not talking anything about left hand limit, it's just the right hand limit that we are talking about, right?
Here,
It's
the
just
left
this
hand
case.
limit will exist.
Left hand limit.
Yes, your
Oh.
left hand limit exists.
Oh,
right?
okay. Thank you.
Yeah, and it will be equals to 3.
Yes.
Like A1
Just-
is why A2 is not.
Sorry.
Means A1 we concluded it is continuous only with one limit.
Okay, so now I'm telling you this.
How do we conclude that it is not?
Okay, I'll come to this. Now limit as x tends to 8 f of x, what is the value? 3.
3.
Right.
Yes, 3.
What is f of 8?
No,
It is not there.
Not
there.
defined. Not defined or not given.
Yes, sir.
Not there.
So is 3 not equals to anything which is not given? No, right? So it is not continuous.
Yes, sir.
Okay. So now this is clear.
Just one second. Can we generalize it as at the boundaries always limit exists?
This is for generalization only. For your boundary condition, that is why I took 2 boundaries. You can generalize and make a note of this.
I was about to ask
The
the same
first time
thing.
we are seeing this type of problem at the
Yeah, I
boundaries.
knew. That is why I thought like this is something not discussed. So let me discuss this here. So just keep this with you, okay? This will be helpful for your intern. You can keep this with you.
Okay, sir.
All right. So
Okay, sir.
this is
Thank-
some and you can keep for ourselves. Like this is something we can make clear. Now, since we are okay with this, since I told we'll do a problem on UV type of integration, and we'll do one, and then we can just wind our session.
Thank you, sir.
Yeah. So let's take one question. So let's take simple problem, x e to the power of x, or let's take a bit difficult one. So it'll help you somewhere else. So you see, you have to integrate this function f of x. Okay.
Yes.
So you have to integrate these functions. Okay. So now you have this rule isolate. I hope you know this. This tells you, this is of form uv. So this tells you which should be u and which should be v, right? I hope you know this, right?
We forgot.
Forgot in
Forgot. It's just started in your
Last.
lecture.
Yeah.
So rule I don't
Inverse,
know.
that
But
order for
Algebraic, algebraic, trigonometric, and then exponential.
Yeah. Inverse.
So
Inverse
maybe I will
of
tell you from beginning if you
algebraic.
forgot this. So now we can see this.
Actually, background noise. Sir, background noise आ रहा है. Please mute all of them.
Okay, so now you see this. This tells you this islet tells you which should be your u function and which should be your v function. Okay, this tells you whichever is in order, right? Whichever is in the first order, that will be your u function. Okay, so let's say if you in your function the first one indicates inverse. This is inverse. This is logarithmic. Oh, my pen is not writing sometimes. Yeah, so this is your inverse. I hope you can see things, right? And I'm audible.
Yes, sir.
This is inverse function. This is logarithmic function. This is algebraic function. Algebraic function means polynomial functions. Okay. Algebraic functions. This is trigonometric functions. And this is exponential functions. So if you take UV, when do you apply this UV? Whichever comes earlier. Now, could you tell me is what kind of function is this? X square. Algebraic function.
Algebraic.
And what is this? This is exponential. So which the algebraic come first, right? So you can just write this U and V, right? So U and V. So this is the priority. So if whichever comes first in this order from left to right, you take that as your U. Okay. So since algebraic comes first and you have exponential, so you take U as this x square. This is your U and this is your V. I hope this is okay.
Yes, sir.
Yes, sir. Yes.
Okay, so now if this is okay, then we'll do the integration part. Just give me a minute. Okay, so I hope this is okay now. So now you see this is UV. So integral of UV says what you should do is, am I audible?
Yes, sir, you're audible.
Yes, sir.
Do integral V minus integral of U dash integral of V. Too much, is it? Okay, so I think most of you will know this, but to those who don't know this, we understood what is our U. U is x square, and what is our V? This is e to the power of x. And integral of UV says what? Integral of UV is nothing but U is nothing but x square and e to the power of x, right? So integral of UV says what? You will leave U as it is. So leave U as it is, x square, and then you will find the integral of V. So what is integral of V?
E to the power x.
E to the power of x minus this integral, let it be as it is. Okay, it says no integral. So what is U dash now?
2x.
2x. And this says integral of V. So what is integral of V?
E to the power
E
x.
to the power of x. So now I'm doing integral of this, and eventually when I was doing, I got another integral. So I should solve that, right? So now I'm just simplifying this. This implies x square e to the power of x minus, now I'll do the integral of this one. Now again, can I say this is in uv, or just I'll just take out this u2 outside, right?
Yeah. Yeah.
So let me take this 2 outside and just open my bigger bracket, and this is again in the uv form.
Yes,
Right.
sir.
Yes, sir.
Yes,
Now
Yes,
I
sir.
can again apply this rule. So this
Yes,
rule
sir.
says what? Keep u as it is. So what is my u? X. I will keep it as it is. Okay. And then I will find the integral of v. So what is integral of v? E to the power of x
E to the power of
minus.
x.
What is derivative of this one?
1.
1. So even if I don't write, that's okay. What is integral of e to the power of x? E to the power of x.
E to the power of x.
Now again, I'll end up having an integral, right? So now let's again simplify that. So x square e to the power of x minus 2. I'm just rewriting everything, right? X e to the power of x. Now what is integral of e to the power of x?
E to the power.
E to the power of x. So I'll land up here. So now again, the next step is simplification. Now I don't have any more integral, right? So x square
Yes,
e to
sir.
the power of x minus 2 x e to the power of x plus 2 e to the power of x. Now you see that the integral of x square e to the power of x is nothing but this one. Okay. Clear?
Yes, sir. Thank you, sir.
Okay.
Yeah.
So you
Good,
can
sir.
practice. You can practice.
Sir,
with
what about
questions.
definite integral, sir?
So definite integral, if there was some limit value, let's say from 0 to 1. So all you have to do is whatever you got this, just substitute value. So maybe I can do that here only. Let's say I was telling you to integrate this from 0 to 1. Now this is my definite integral. So when you do this, now after finding the integration, whatever the value you get, you substitute this 0 and 1. So what do? X square e to the power of x minus 2x e to the power of x
Plus 2e to the power of x.
plus 2e to the power of x. So just plus 2e to the power of x. And then you substitute this integral values, right? From 1 to 0. Now, when you do this, what do you get? You just substitute these values. So first this value. So when you substitute this 1x square. Oh. Yeah. So now when you substitute this value, what do you get? I'm doing this 1. So when I substitute 1, so I get 1 square, which is nothing but 1. And e to the power of 1 is e minus 2e minus 2e again, right? Is this okay?
Yes.
Sorry, this is plus 2e. No? This is plus over here. Right? Okay. So now this is what I get after substituting this minus of this. Again, now I'll be doing everything for 0. Right? So now when I substitute 0, x, here I have x times anything is 0 only. Here also I have x. So this will again give me, so it's like 0 minus 0 plus 2. So now I will just simplify this. So now what do I get from here? 2e, e, 3e. So I will have e minus, this will give me 2. So finally, after simplifying, I get e minus 2 when I substitute the integral value. Okay. So you can practice these kind of questions. You can take some questions like this. You have a lot of questions in your NCERT books. You can take some random questions from there and you can do this.
Can you take one example of rational functions?
Rational functions. Could you give me one example?
So anything kind of e power x minus 1 divided by x plus 1.
Minus e power x minus 1.
Or something divided by x plus 1.
Okay, so you have this in u by v form.
Yes.
So when you have this, again, what you can do is you can split this into this form. Right. But, but again, that is something we will not give, and that will always not satisfy this condition, UV condition. You might land up somewhere else. So we can ignore, maybe we are not giving more emphasis to that here. Okay.
And what about
in u by v form? Sorry, I'm get.
See, when you have this u by v form, you have some different formulas basically. It's not the same way, but one way of doing is you can take u into 1 by v. Right. So you can do this. Let's say you have e to the power of x
into 1 by x.
So 1 by x will actually, this is more troublesome. You will
Will
keep
it not
integrating
be
it.
x inverse or something we can solve?
You can take 1 by e to the power of, or not e to the power of x. You can take this as some different values. Maybe you can take this as
X plus 1.
cosecant. You can take this as cosecant x, cos, or cosecant x you can take, and then integrate this. This falls under your trigonometric thing. So which will be your u and which will be your v here?
Isolate. We have to follow
U
isolate.
will be 1 by cosec
Isolate,
x.
yes. This is a trigonometric. So trigonometric is this, and this is exponential. So of course this comes first. So this will be your u and this will be your v. Okay. Okay.
Yes, sir.
And what about inverse functions? Tan inverse x.
Tan inverse. So you have direct formula, right?
Integral of tan inverse.
You have that. We have given this direct formulas.
Yes, sir.
Yes.
If it is given, then we will give you in your exam also. So no worries about it.
Sir, I have a doubt. 9.6 activity question number 4. It's very simple, sir. Can you just
Okay,
open
so
that?
fine. Anyways, we are done with this now. So I will just open that and then we can end our session.
Yeah.
So which one?
9.6 activity 9.6.
Okay.
Question number 4.
Okay,
Sir, this is very simple. I know, like direct formula is there for this even function and odd function. But the thing is like this x to the power of 2021 and cos. How we are doing this? We are multiplying it. Like I know this is one of them is odd function. Sorry, even function. Like cos 2021 is even function. And
Cos
x to the power
2021 is an odd, no?
cos
Sorry,
of
yes. Cos 2021. Yeah. Please go ahead.
Oh, even functions.
Yes. Please go ahead. Yes.
And we are multiplying it with this x to the power of 2021. So final product will be what? Like I'm getting confused in that. Like it will be odd function or it will be even function.
No, this last class, ma'am explained.
You can actually see that video.
But I got confused because of
The
this.
sine function is odd, so we can do it.
You can rewatch that.
Final answer, you will get a 0.
You will get it. Yeah.
Okay, sir. Okay.
All right. Yeah. All right then. Thank you all.
Excuse me, sir.
Yeah.
Hello.
Yeah. Please.
Yes, sir. I have one query regarding quiz 2, sir. It will take just 1 minute.
Tell me.
Sir, is it mandatory to appear in quiz 2?
No, it is not.
Or you will take a best of quiz 1 or quiz 2?
Yeah, best.
Best one.
Best of this thing. So even if you don't write 2, so we'll take your quiz 1 score.
Okay, sir. So if I don't appear in quiz 2, that's not a problem.
That's not a problem. Yes.
Sir,
okay, sir. Thank you, sir.
Sir, actually, I do have a question. So, if suppose I want to improve my maths score, so should I participate in quiz 2?
Yes,
I don't want to improve my English scores, but maths scores I want to improve.
Then go write it. Yes.
Okay.
Yeah.
Sir.
Yes,
Hello.
please. So,
sir.
Hi, sir. So actually, just want to know, मैंने 8th और 9th week बिल्कुल नहीं पढ़ा है. So how can I go about it? I mean, should I watch all the videos or should I do this activity session which you guys have taken?
Like you belong to maths background?
Yeah, I was, but 15 years ago.
Okay.
But I updated myself till week 7, but 8 or 9 somehow नहीं होगा because I'm working also. So how can you go about it?
So
I mean, how
what
should
you
I?
can do is see week 7. If you know week 7, that's good. So now in week 8, what do you have is like limit, continuity, and differentiability. So it's basically, in a way, it's the continuation of limits only, right?
Yeah.
So if you are thorough with the limits, then you will not find it difficult. So what you can do for time being, if you don't want to watch a lecture or something, or just directly, what I would say is just go with Solve with Us. Okay.
Okay.
Solve with Us in the sense, not this session, but the slides what you have. Just go through them. If you can see if it is comfortable for you. I mean, since in Solve with Us, I think they have already given you some kind of informations how to solve those questions, right? So you just go through those informations and try attempting those questions. If you are able to do it, then you will not find any difficulty. But if you find that you are having, you need some concepts to be, supplemented, so you can always see Sir's video, or you can see our live sessions also, wherein we have discussed all this, right? So you can do that. So wherever you feel like you need supplement, so you can do only that part, right? And see,
So the thing that I should go with the other lecture, other than this solve with instructor, I should go for the activity sessions first. And
no, what I meant is Solve with Us session, in the sense we have given some slides like this, like you will see Solve with Us some week 9, and you will see some information and some questions are already given in the portal.
Okay.
So try doing those questions by going through the information. So if you're able to do it, perfectly fine. Don't have to see any videos or anything. But you can, and wherever you feel difficulty, you can always attend any of these sessions, like live sessions what we have taken, right?
Okay.
Or you see for week 8, I think there is one revision session video also, right? You can see that video, so that will be helpful. So that's not very lengthy video, it's a hard video. Or
that
like whenever,
session is also in the week 8 videos only.
yeah, so you can watch them, so that will help you. So I think week 8 you still have time, you can score really good marks in week quiz 2, because you have a lot of time now, so you can start practicing. So wherever you feel you need supplement, just go through it. Okay.
Sir, whatever the slides which you have just now shown us, I don't see it anywhere in the.
Okay, so I'll show you here. Just give me a minute.
Solve with Us. It would be in Solve with Us.
Yeah, Solve with Us. So you see this? This is what, no? You can see my screen, right?
Yes. But
So
in Solve with Us, I can see only the Solve with Us questions. But I'm speaking about the written what you have shown.
I'll tell you that. When you go with Solve with
It would
Us,
be in between the questions.
you see here, these key points. It's basically the same thing. It's the same thing.
So, but
It's exactly
whatever the printed content is not
you mean
available.
the PDF thing, right?
Yeah.
PDF thing, I that is not available. Yes, I guess.
Okay. Yeah.
And one more thing, sir.
Yeah.
This week 9 syllabus is not included in quiz 2.
Yes, yes.
No?
Yes.
Okay.
All right.
It's
so
just 4 to 8,
not
right?
4, 1 to 8.
Yeah. Okay, sir.
Yeah.
Thank you, sir.
Yeah. All right.
So we have given the criteria for the calculation of final score. So I mean, those who are attending only one quiz, they will be affected with 5%, right? I mean, 5% would be deducted if any one of the quizzes not been attended. Is it so?
No, see, in your final score, we add your quiz score as well. You got it?
How much percentage?
Yeah, that I'm not aware of. Let's say if it is of 100, then it has got a significant weightage, like some 20% or something. Not sure of it, but yeah, this is what it is. So if you don't attempt that, if you have not attempted any of the quizzes, then you are certainly losing some 20% or some more than that marks or something in your final scores, which is something not wise to do. Yeah.
Sir, you mean to say quiz 1 and quiz 2, the best one among them will be
anyone, yes.
And that will be counted 20% to the final marks in the term
final
exam,
score.
right?
Final score, yes. Not 20%. I'm not sure of how much percent, but roughly should be so much. Yeah.
No, if the final term exam, let us say someone scores 90%, now this will add up to 98%. This quiz marks.
No, it will not be add on to it. Let's say if we give your end term exam and if it is of 100 marks and you wrote for 100 and you did not attempt any of the quizzes, but your final score will not be 100. It will be something
It will
80.
be okay. No, let us say I have attended quiz and all, but I
Let's say you
attended
attended quiz and you scored 20 marks, like on and on marks, and for your end term you scored on and on marks, then you get 100. It's like that.
Okay.
Excuse me, sir. One more question. Like, I mean, those who are qualified in the January term and those who have qualified in the November term, I mean, the final score calculation would be same or it would be on different formula?
Sorry, could you repeat? Hello?
Those who have qualified in, excuse me, sir, am I audible now?
You will have to write, even if you have qualified, you will have to write any one of the quizzes, either quiz 1 or quiz 2.
No, sir, I'm not asking about the quiz. No, sir, I'm asking different question. Like the final score calculation formula that's have been announced to us, would it be same for those who have qualified in November term and those who have qualified in Jan term? So for both of the students, the calculation of final score would be same process.
Yeah, but what was the process discussed? It was like this thing only, no? Like quiz 1 and
I don't know about those who are qualified in Jan. For the November, it is been cleared for us in the announcements, but it is not clear for those who have just qualified in Jan term. So I mean, in the January month, whoever have been qualified, how do they can refer? I mean, how it is being calculated, everything.
Okay, so I'm not aware like what announcement was made, so I cannot give any. I cannot conclude anything, you know. Like,
Okay.
So yeah. So
Okay,
sorry about this. Yes.
But for the next class, please check, sir.
Yeah,
is
sure.
the final score calculation criteria would be same for each and every term students, or it would be different for Jan qualifiers and November qualifiers or something? I mean, if there is any difference, so please check out, sir.
Sure. I'll inform you. Yeah.
Sir, any quick tips for scoring good marks in mathematics, sir? Quick tips
for quiz 2.
Yes.
Attend live session.
बता दीजिए सर, थोड़ा सा मतलब confidence आ जाए.
Especially revision session.
Yeah.
Revision से तो होगा. Okay, revision
so
session
many
तो होगा,
experienced.
but yeah, that will be there definitely revision session. But before that, if you can just throw some lights. Okay, these are the things we need to keep in mind so that we can.
Okay, so anyways, the paper we have made is we have already made the paper. So, so if I can think of like what we gave more emphasis to was like composition of functions. Of course, that is important. Your calculus part is very important. Week 7 and 8. Yeah. And week 5 and 6, even they are equally. I don't know what to tell you. Like, I don't know. Like, if I have to tell you, I mean, what to focus on, it's basically the tough part of your, any of these weeks that you have to focus on. Okay.
7, 8, sir. 7, 8, and 5, 6.
7, 8. If you are good at graphics, you can do a lot. So that you can do. Plus, these kind of questions, like question is not really difficult. Now you have this limits as well. Then you have the differentiation concepts also. So like L'Hopital's rule, right? Then some concepts of limits. Like maybe I can tell you this more in the revision session sometimes. But if you are to ask me like what to focus, you have to focus everything from week 5 to 8. Yeah, because there is nothing which we have left. We have covered everything in your quiz. So I cannot actually pinpoint and say, yeah, pay attention to this. At least in some live session, I have marked somewhere, some triple star. You can practice that. I don't know.
Okay, sir. 1 to 4 में जो ज़्यादा नहीं है ना, focus मतलब 5 to 8 में हो जाएगा.
See, it's not much and you have time from 5 to, this is where you should test your caliber, right? I mean, you have been given a lot of time now, and you have some tough part of your maths, and if you can cope up this situation, then I think rest all are easy. You can score really good marks. Okay.
What about the next revision session, sir?
Next revision session is going to happen on Tuesday, but as you are telling to have one before
Not
mock.
sufficient, sir. One is not sufficient.
On Friday, sir. This Friday.
On Friday, okay. So maybe we'll just discuss with the team once. We'll certainly try to keep one on Friday or something.
Actually, especially आपका जो session है ना, it should be more sessions.
So maybe I will only be taking if it is on Friday. So let's see, because Tuesday is fixed. So.
Sir, the mock will be on Sunday from what time to what time?
Sunday 7 to 9.
Okay, so it will be of 1 hour, but we can attempt it any time between 7 and 9, right?
So you see, I think we are keeping it for 2 hours. Some of you were actually asking for this supplementary assignment, something like this, right?
Yes.
Yes,
sir.
right?
Yes, sir.
Okay,
Yeah.
so for this we thought like, we can keep your mock 2 as your supplementary assignment for those who wants it. That's why we have increased the time for 2 hours. Otherwise we would have given 1 hour. But it will be for 2 hours.
Sunday or coming Sunday, I didn't receive any notification regarding
This is some some secret things which I'm telling you, which will be announced like in a day or 2.
Okay.
Okay, sir. So
Alright.
will the mock test score be counted?
No, that
Those
score will
who-
not be counted. But those who wants that supplementary assignment, I think Krishna ji was telling, right? Previous
Yes, sir. Yes,
assignment,
sir.
like,
Yes, sir.
so we totally understand that, but that's what we thought. One thing is something we can keep this mock itself as one supplementary assignment just by increasing time for 2 hours.
Okay,
But when you are solving mock, just take it seriously and try to solve within a hour. Okay. Do not
Yeah,
think
so
it's
the
perfect.
questions are for 1 hour.
Yeah.
Okay, sir.
So you take it, treat it like that, and then solve. And then you will complain it is lengthy because because the moment you give 2 hours, no, you will be like, oh, there is 2 hours, right? And then you'll be like, this paper deserves 2 hours. So it'll turn out to be lengthy.
But in the
Whatever
final,
we
but in
will have
quiz
some.
too,
What about in quiz 2? Will they give extra half an hour?
No. Quiz
While
2.
making question paper, na, please consider the diversity of the
Yes,
students.
yes,
We
yes.
are not all are youngsters.
Hmm.
Our response time is
Yeah.
much lesser than the youngsters. They will do
Yeah,
very
yeah.
quickly.
Definitely, when
Yeah, it's very-
when we are preparing paper, we do segregate like easy, medium, and tough, but not very easy. So that is something we pay attention to.
Actually,
And
when it comes to the calculation part, we are unable. I mean, it's taking
but
too much
I don't.
time.
Does it any of the problem involves a lot of calculations in your quizzes? No, right?
Last time, no.
You will never have it like this.
lots
Only
of
logical understanding. If
Yes,
the-
yes,
I mean,
and I will guarantee you, if you know things, if you can visualize things, for most of the question, you will not even have to touch your pen for writing anything. If you can visualize things.
Through graphs.
So that is something we can keep. Yeah.
It is not
need to
about
practice a lot.
easy or difficult, but it's a time consuming, sir. How many questions actually are? I mean, can we know that?
For your quiz too.
Yeah.
So
Quiz too, sir.
something like 16, 17, something like that.
Oh, 15 would be enough.
17, yeah, same
Actually,
like quiz 1.
So same like quiz 1. We prepare, as I told you, 10 questions, and then we make that sub questions, right? So eventually your number of questions increases. That.
No.
Yeah, so that's what we do. Like
10 questions was easier, sir, without having sub questions. Like last time it was very easy. I mean, I was able to finish it in 1 hour, but quiz 1 has taken more than 1 hour to finish.
I get it. But like we also have to consider this thing, like the other students, who cannot score, like who cannot arrive at a final answer, or like who has arrived at final answer and made a mistake, finding the answer. So they would lose a bulk of marks. Like, let's say if it is of 6 marks, they are losing entirely 6 marks. But if we create 2 part in this, so at least they have another chance of scoring. At least
that happens often with me.
Yeah.
I go wrong in the calculations in the hurry.
Yeah. So that's what happens. Yeah. Then we also thought of giving some step marks, but when we were thinking about it, so then we were actually coming up with numerous steps, which would have taken a lot of time for you to read the question and the steps itself. So that was not feasible. So we thought, like, let's create these sub questions. So essentially we make questions. So see, Abdullah, what it is like, when you are solving a question, just take it as a big question and you try solving it. It's just that you have to give the answers for those sub questions. That's all. I do understand it takes time to read a question also, but you can practice that. It's okay. Okay.
Okay, so thank you.
Yeah.
Thank you, sir.
All right then. Thank you, everyone. Good night.
Thank you so much.
Revision session.
Thank you so much, sir.
Yeah, revision session. Yes, we'll keep it on Tuesday, and we'll see if we can keep it on Friday also.
Thank you very much, sir.
Thank you very much.
Thank you, sir. Could you wait 5 minutes for me? I
Thank you.
need some clarification in one graph.
Yeah, sure.
If you are free,
Yeah, tell me. Yes.
I'm unable to plot minus logarithm polynomial. I'm facing difficulty.
Yeah, actually, I saw you asking elsewhere too. You can see my screen, right?
Yes. Logarithmic polynomial I'm able to do, but minus log.
Okay.
I'm unable.
We can just do this. So take a graph. Okay. So log x, so this is your log x, right?
Like this is okay if you have
No,
a
I'll
big
come to this.
polynomial inside
Okay. So let's take that also.
with some factors, 3 or 4 factors.
Let's say you have this. Let's say you have. Okay, my pen is not writing sometimes, so just give me.
It's okay.
Let's say you have this 3 points, and there was an asymptote here, and this was going like this. Okay, and then you say there is another 2 asymptotes, and this is what happening. Okay, so now this is your some log of something. Okay, so when you take negative of this, so what does this means is, I'll use different color. So now let's say this was 5. Okay, let's say this was something 5. So when you take, and this is your f of x, right? And this is giving you 5. When you take minus of f of x, what does this give you? Minus 5?
Minus 5.
So can I say that this get tilts like this? Then this get inverted like this. Something like this will happen.
I'm unable to understand.
Okay, so I'll make you understand now. So now understand this. Let's say this is 1, 2, 3, and this is log of x minus 1, x minus 2. Okay. X minus 2 and x minus 3. Okay, so this is the graph for this thing, right? So now you take negative of log of all these. Okay, we'll take one example and we'll see if this works out, right? And x minus 3. So now you see this. When you take let's say 3, right? So let's say you're taking 10. When x is 10, what happens, right? So when you take x equals to 10, so this will give you 9 times 8 times 7. So right?
Yes.
So that is some positive value which is going to happen over here, right? So let's say that positive value is something a. Okay. Now same thing, but the negative value comes in. When you say minus f of this, so you, no matter what, your x is still 10, right? Your x is still 10, right? So when you substitute this value, it turns out to be negative value of this. So if this was a, So certainly this is going to be minus a for the same particular value of x, right? So it's just get tilted.
Okay, now understood.
Understood. Now I'll tell you whether you understood or not. Let me understand this first.
Okay.
Okay, so now you understood that this is the graph for f of x, and now you got convinced that if minus f of x is this, then this is what happened, right?
Yes.
Right. So now if you had this, or maybe this is not the right example for this discussion. So let's say if this was f of x. So sometimes you also see a situations. No, it doesn't happen for this one. It's actually happened for algebraic function, but for logarithmic, I think this is good. Whatever you understood, that's perfectly fine. Okay. Okay, that will do. So negative, when you take negative of this, it's just everything, your f of x becomes negative f of x for the same particular value of x, right?
Yes.
Right. So yes, that is okay. So
You
thank
can
you.
say it's mirror image of x axis.
Along x, yes. Yeah. Oh, there were so many. I thought you left. Yeah.
Sir, sometimes now we are flipping along x-axis, and also we sometimes along the y-axis also, right? That also again flips, right? So in that case, like f of x minus of x will be good, right? If f of x
So
is
that is
equal to
different.
the
that is different. What you are telling is
flipping along y-axis.
So that is different thing. Again, like when you say that you have that condition, right? When you have log x, then you have log of minus x.
I'll give you one function. Can you help me to draw?
Yeah, sure.
Minus log.
So yes, tell me.
Not visible. Your notepad is not visible.
Okay, notepad is not visible. Okay. Oh, just a minute. Something happened. Okay, just quickly tell me now so that we can.
Minus, still not visible. Okay. Minus log minus x minus 2
Okay,
into
just
x
a
plus
minute.
5.
Minus log.
Minus x minus 2.
Minus
inside.
of, is it?
Minus of x minus 2 into
X
x
minus
plus 5.
X
2
minus
into
X minus 2.
Yeah. X
Okay,
minus 2 in the bracket. X minus 2 in the bracket.
Okay. X
Into
minus
x
2.
plus 5.
X plus 5. Okay.
Yeah, keep minus in front, x minus 2.
Okay. So if you are
Negative
to ask me
polynomial.
how will I do the graph for this?
Yeah, it's a negative polynomial.
I will forget about this negative part first because I'm not very
Here
comfortable.
also, in front of x minus 2 is also negative. It is minus x
Here.
square. Yeah.
Okay, that's okay. So you know this. First, I will do the graph for this one. Okay. Then I will
Yes.
consider this. So first, I'm
Okay.
considering I don't have this negative here, right? So let me consider f of x when I don't have this negative. So now you know this. What is the leading coefficient?
Negative minus x square.
And it is odd.
Yes. Even x
So
square.
even. So it is going to happen on the same side. And where is that happening? This is minus 5 and this is and this is 2, right? So parabola will open downwards, right?
Yes.
Negative
Yes.
and even. So it will happen like this, right?
Yes.
Okay. So now I drew the graph for this part, just this part. Now I'm going to do the log of this, right? So when I do the log of this, what happens to the log of that? This will happen at this point. It will become vertical asymptote, and
Yes.
this will go something like this.
Yeah, it will run inside the parabola.
Okay, so now this is my positive f of x.
Yes.
Right? This is my positive f of x. Now, could you tell me something about negative f of x?
This will shift upward, up and down.
Exactly. So what will happen? This will form our vertical asymptotes, and this will come like this. Right?
Yes, now clear.
Now clear? Okay.
Yes, clear, understood. Thank you so much.
You're welcome. So all right. So thank you then.
Sir, just 1 minute. Can you please go to the graph, please?
Same graph.
Yeah. Just a minute. So अंदर वाला जो माइनस साइन था उसके लिए आपने कुछ किया क्या? Did you
हाँ,
do
उसके लिए
anything
मेरा
for-
देखो ये जो था हमारा इसका जो ग्राफ जो था उल्टा हो गया। अगर ये पॉजिटिव रहता तो ये पैराबोला अपवर्ड खुलता ना ऐसे।
लेकिन अंदर वाला जो माइनस एक्स माइनस
हाँ, मैं उसी की बता रहा हूँ। ये देखो, जब ये पॉजिटिव रहता तो ये ऐसे खुलता, लेकिन जैसे मैंने नेगेटिव दे दिया तो ऐसे खुलेगा।
ओके ओके ओके
है ना, वही मैं बता रहा था कि लीडिंग कोएफिशिएंट इज नेगेटिव एंड इट इज एन इवन डिग्री, राइट? सो व्हेन इट इफ दिस इज हैपनिंग, आई फर्स्ट ड्रू द ग्राफ फॉर दिस वन, नेगेटिव को कंसीडर करते हुए, राइट? ओके ओके देन, थैंक यू।
Thank you so much, sir.
Thank you
Yeah,
so
thank
much. Thank you. Thank you, sir. Thank you, sir.